Hi, my name's Taranda, and I'm with the Revolutionary Alliance for Truth and Democracy. Our website is raftd.org. This video is on the Apollo moon landing hoax. I've done a couple of presentations on this topic at the College of Complexes here in Chicago. In fact, I've done a number of presentations on various false flags, hoaxes, and other huge deceptions by the U.S. government. The general theme has been USA, Empire of Deception, Tyranny of Lies. My overall goal politically is achieving democracy in this country. But evidently, conventional issues, and these here are obviously groups of issues, like economic oppression, imperialist war, environmental destruction, have not been sufficient to spur the people to do what we really need to do, which is to undertake democratic revolution. The populace apparently needs a much bigger shock than ordinary issues, no matter how important they are, can provide. Learning that the government is the perpetrator of the greatest criminal deceptions in the nation's history might finally awaken the people to the imperative need for total system change. And among these great crimes and deceptions has been the assassination of John F. Kennedy and his brother Robert F. Kennedy, and throw in Martin Luther King as well. The supposed attacks on 9/11, which was, as has been often said, an inside job. And these crazy, obscene, and absurd mass shooting hoaxes, which are becoming almost a monthly occurrence nowadays. The Apollo moon landing hoax fits squarely in this category of massive deceptions and crimes. Effective investigation of most false flags and hoaxes requires open-mindedness, diligent research, and logical and scientific thinking. In other words, common sense more than professional expertise. However, in this case, that is Apollo, my experience as an advanced amateur astronomer has been very helpful. And this is the book I wrote, and the title is 3,000 Deep Sky Objects. And deep sky objects are objects beyond the solar system. So galaxies, open clusters, nebulae, instead of, say, planets. And what I did was I designed and built this special telescope. It's a binocular telescope. That's one powerful telescope for each eye, so that I could see things as clearly as possible. And I took this telescope to Arizona and New Mexico and Nevada, the Southwest U.S. deserts, in other words. And I'm showing this photograph to show the scale of this thing. And so I took this telescope down there and I looked at all these objects from all the major deep sky objects visible from the northern sky, and I wrote up my observations, and that's the book. So this was obviously a very major project, and it honed my powers of observation. Now, as for Apollo, these were without question fake. Criminal deceptions by the government of this magnitude are utterly unacceptable, to say the least, and the American people must respond to them appropriately. This requires that we know with certainty what's going on with these events, what our rulers are doing, and we can know this by examining the evidence, carefully, objectively, and scientifically. Here's what a couple investigators say. Bart Zabrell: I'm absolutely convinced. I'd bet my life on it that we didn't go to the moon. I know for a fact that we didn't. Dennis Semino says, it's absolutely certain. Not probable, but certain. I'm not 99.9% certain. I'm 100% certain. All of the evidence proves we never went. It was a very elaborate hoax. This is the quote-unquote table of contents, if videos had table of contents. And I'm not going to go through all of this because I hate long introductions, and I'm going to talk about it also why I talk about it now. But you can look it over, you can pause and look it over. I just want to point out where these asterisks are. These are subtopics that I'm covering here, either for the first time or much more deeply than ever before. So this would be new material for anybody who might already be somewhat familiar with this subject, just for your information. So I'm going to start off with this famous photograph, one of the most iconic photographs in the 20th century, certainly the most famous photograph from the Apollo missions. And there are three things in this photograph that prove fakery, that this didn't happen on the moon. Okay, and so the first of these is, notice where this horizon goes across in relationship to the astronaut. It goes across his face. And that is impossible, because the astronauts had their cameras always at their chest, like Neil Armstrong does there. That's in the visor of Buzz Aldrin. This is Buzz Aldrin. And the astronauts always had their cameras at their chest. As a matter of fact, there was a bracket there on their spacesuit to hold the camera. And notice where the horizon is here in these frames from a film. It's at their chest, where the camera is. And that's how it has to be when two astronauts, or two people, actually, any two people, are standing just a few feet away from each other with their cameras at chest level and taking pictures of each other. The horizon has to be at their chest. It's a very basic problem of geometry, and it's a fact. So you see this astronaut in this guy's visor. He has his camera at his chest. Okay, this is how it should be. Okay, this is when they did it correctly. The photo that I started with, that famous photo, it was done incorrectly. Here is a photograph I took of myself, and to do this, I put a camera on a tripod, and I put it at my chest. Okay, the camera at my chest. This is another photograph I took, and here, oh, by the way, did I mention in this photograph, the horizon is at my chest. That was the first photograph I took. In this photograph, I made it so that the horizon was at my face. And to do that, I had to raise the camera by over a foot, and I had to put the tripod on this stand. Okay, and so there's the camera now. That's a big difference, a very big difference in relationship to the height of a person. You can't dismiss that. When two people are standing on reasonably level ground, and there are some pits there, but that's not significant. That's just a matter of inches, not feet. And so that when the terrain is reasonably level and two people are standing close to each other and they're of about the same height, which Armstrong and Aldrin were, you have to have the camera the horizon at chest level, where the cameras are. So they got it right sometimes, like here. They got it wrong other times, like the famous photograph. And here's another case where they got it wrong. So what's going on here? What's going on is pretty simple, actually. This photograph was not taken on the moon. It was taken on a moon set here on Earth. And probably for all these photographs that we're going to be looking at that are allegedly from the moon, all of these photographs were probably taken by professional photographers, not astronauts at all. The people inside these suits may not have been astronauts all the time. That could be the case. But at any rate, so they made mistakes, like here. And so this photographer in this case undoubtedly put the camera up to his face because he was taking a normal photograph in the normal way. He forgot to put the camera down at his, or take the picture from a position which is equivalent to chest height. So that's what happens when you're faking things. You get it right sometimes, you get it wrong sometimes. Reality is just what it is. It's not right or wrong, it's just the way it is. You don't make mistakes in reality. Or you do, but that's another story. And the Apollo program was very long. It was about 4 years long. The landings, the part of it with the landings was about 4 years long. It was a huge, complex project, and you make mistakes when you're faking things so complicated. Okay, let's move on to the second problem with this photograph, and that is that the astronaut is clearly standing under a spotlight, and the ground is very unevenly lit. So this is impossible for two reasons. One, the astronauts didn't take any huge lights, floodlights, spotlights, any large lamps to the moon. And as NASA says so itself, all the outdoor lighting was supposed to be by sunlight. Secondly, on the moon, there is no such uneven lighting at all, except for maybe right at sunrise or sunset. And here you see the indications of a fall-off area. That is a photographic term when you have a spotlight and then you have the darkened area around the spotlight. There is no dusk or dawn or twilight on the moon of any significant duration, only day or night, because of the lack of an atmosphere. The sun is either in the sky or it is not. Therefore, the landscape is either brightly lit or it is black. Ground illumination by the sun anywhere is even or uniform, assuming reasonably level, homogeneous terrain. No large lamps were taken to the moon to provide extra lighting, and NASA affirms this. So for these reasons, this what we're seeing here is not on the moon. This is not a photograph taken on the moon. They corrected this problem. That original photograph was from Apollo 11. This is later missions, so they corrected that problem. This is how the lighting of the ground should be. It should be completely even. Just like it's even around me here and around my telescope out there in the desert. There is no concentration of light, and there would be no reason for any such concentration of light. Here are a couple more photographs from Apollo 11, and you can see the spotlight effect, especially in this photograph. It's very clear. So what we're seeing, without doubt, is lighting by spotlight, a floodlight of some sort. Maybe not necessarily quite that focused, but a floodlight nonetheless. Artificial lighting, in other words. And here is a soccer field lit by natural sunlight, and as you can see, there's no concentration of light anywhere. Here is a soccer field at night, and there's obvious fall-off area around the field and even inside the field, because the illumination is not going to be even with floodlights across a very large area. Natural sunlight, even through clouds, the sunlight diffuses the light, and it's all around. Here the fields are lit, and of course they don't want to light up the entire neighborhood, so clear-cut fall off around the field. The third problem with this photograph, and we're talking about major problems, there are probably other problems that some other investigators have seen as well, but the third huge problem with this photograph is that this astronaut should be completely black, okay? At least extremely dark, if not literally completely black. And that's because on the moon there is no atmosphere to diffuse the light, which is what causes what would be dark shadows on the Earth to be reasonably well lit. So here you can see how well lit he is. If that were writing, and you could focus, and the photograph was better focused, you would be able to read it. Everything is perfectly well seen. That would be impossible on the moon. All shadowed surfaces on the moon are extremely dark, pretty much black, since unlike on Earth, there is no atmosphere to scatter, diffuse, and spread the sun's rays and thereby illuminate surfaces not in direct sunlight. Light-dark contrast is extreme and severe. It is the moon's total lack of an atmosphere that renders its surface so sharp and clear to our view that we can see minute detail on it all the way from Earth. So this is an amateur photograph, and we're going to rely mainly on amateur photographs because you can't trust most Apollo photographs, NASA photographs. And you can see how inside the shadowed areas, it's completely black. And this is how all photographs, properly exposed photographs of the moon are. Like inside that crater, it is pitch black. Here's a well-lit side of a crater in the sun, in the sunlight, and here on the shadowed side, it's black. Same thing with this mountain, this central peak, well lit on the sun side, black on the shadowed side. And here's another central mountain. This is actually from Copernicus, and same thing, black shadows. The Earth is a different story. You have shadowed surfaces which are quite well seen. This peak is casting this shadow, and you can see inside there. This is a low light situation, probably near dusk or dawn, and still you can see inside there. And if you were standing in there, of course you would see things. You know, you wouldn't have trouble seeing anything in there. This is a special case. This is Meteor Crater in Arizona, also known as Barringer Crater. It's the best preserved large crater, meteorite crater on Earth. So it looks very much like how moon craters in general look. And you can see right into it even with the shadow. And here's a man standing in front of Meteor Crater, and you can see his shadowed side for the same exact reason that you can see the crater's shadowed side. It's because of the atmosphere scattering light. The correct definition of daylight is sun-illuminated atmosphere. On the moon, there is no such sun-illuminated atmosphere. So if you had an astronaut standing here and you were photographing him, let's say you were on this side, on the right side, and you were photographing this astronaut standing on the rim of that crater, like this guy is standing there, okay? And you took his photograph with this side of the crater in the background. This would be black, just like it looks right there. And the astronaut himself would be black for the same reason, that they're not receiving direct sunlight. The astronaut would not look like this. He would be black. Now there is a special case on Earth where you have very dark shadowed surfaces, and that is in low light silhouette situations. In fact, it's a genre in photography called contre-jour, and it can be a desired effect. But let's say you wanted to light up these shadowed subjects, okay? What would you do, or what would you have to do? You'd have to overexpose it. That would be one option. Overexpose the photograph, and then you would see how dark it is under this porch and inside that window. Well, you can light it up by overexposing the photograph. Okay, but of course that would ruin the overall picture, so you wouldn't want to do that. But there's another option, and that's using low light flash fill. So here you have a woman in a silhouette situation. She would normally be dark, her shadow would be dark, but here she has no shadow, and that's because the photographer is using the flash on his camera. Another term for this is fill flash with backlight. The key is backlight. So here he is photographing this woman and into the sun, and here's what you get. You get a dark subject. So what does he do? He uses his flash on his camera. You can see how it lights her up right there. And lo and behold, you have a well-lit subject even in what would normally be a silhouette situation. On the moon, or rather in the Apollo photographs where they're allegedly on the moon, you have clear-cut silhouette situations. This is supposed to be the moon, excuse me, this is supposed to be the sun, but of course it's not. It's just a bright spotlight. And this photograph is probably taken indoors. It's undoubtedly a moonset. It's probably an indoor moonset, which would normally be dark, except for that light. Okay, and this is a silhouette situation. This should be dark. This should be quite dark. And here, this is Apollo 11. This is Buzz Aldrin climbing down from the LEM, allegedly. Okay, he should look dark, at least as dark as that woman there. If he were on the moon, he would be completely black. But even in an Earth studio, in this situation, in an indoor studio with that light, with that bright light, he should be dark, just at least as dark as that woman there. So here he is, inside, still inside the cabin of the LEM, inside, and on the shadowed side of the LEM, and you can see clear as day. And there again, here he's climbing down. And notice here his boot. There's a hot spot. That's a photographic term, a hot spot on his boot. That indicates a specific, definite source of light, secondary light, apart from the alleged sun being used to illuminate the shadowed side. And here he is again, and again, look at the boots, hot spots. Okay. So a secondary source of light was certainly being used. And here's another case where the astronaut should be dark. If he were on the moon, he'd be black. Even in an indoor studio with the light up there being the only source of light, he should be pretty dark, even on Earth. But he's well lit, and that indicates that a secondary source of light is being used as backlight. And this is an animation to show how the astronaut would look if he were really on the moon. He would be black, and so would the moon rover, by the way, that side of the moon rover. Whoops. There you see the difference. Okay, again, and these are not isolated cases or instances. This happens again and again, where you have clear-cut silhouette situations. There's no way in the world that this should be or would be so well lit if this were on the moon. So what they did was they flashed or they used some lighting, okay, to light up the shadowed side. It's that simple. That's what they did. And notice that when you do that, you don't illuminate the ground very much. Okay, the ground is relatively unaffected. So here in this photograph, this original photograph again, you can see evidence of secondary lighting, and you can tell that from the dark surfaces in this photograph on the shadowed side of that astronaut, on top of his helmet, on the top of his backpack, and the top of his shoulder. Why would that be? Why would you have that differentiation in the lighting between those surfaces and the vertical surfaces? In reality, if you were on the moon, he would be dark, and he would be uniformly dark. And even on Earth, in a studio with that light up there as the only source of light, he should still be uniformly dark. This difference in the lighting of horizontal and vertical surfaces, he's well lit on vertical surfaces, that indicates a secondary source of light being used. Now this here is a beautiful case study showing the necessity of backlight, secondary lighting, to illuminate shadows on the moon. The absolute necessity. What this photographer did was he took a well-exposed photograph of Tycho. This is Tycho crater here. Okay, and then he deliberately overexposed the photograph, so to light up the inside of Tycho, which he succeeded in doing. That's the original, or the first photograph he took, I should say, and then the overexposed one. So he wanted specifically to light up the inside of Tycho, and he did. But what did that require? It required a huge amount of backlight. Tycho is 53 miles in diameter, 53 miles across, and that crater rim provided an enormous amount of backlight. So lighting up the inside of Tycho crater took three exceptional conditions. One, the overexposure of the photograph. Two, a huge amount of backlight, sunlight reflected off a 53-mile diameter rim. And three, a relatively young crater with a well-sculpted vertical rim, which is what Tycho had, as you can see there. Okay. Now, look at the other craters near Tycho, which are almost as big, okay, but they don't have that nice rim on the sunlit side, okay, it's like Tycho does. So you don't have a whole lot of backlight, and they're dark inside, they're black inside. Now, interestingly, and same thing with these small craters here. Now, interestingly, these craters, these small craters here, are young craters with nicely sculpted rims, okay, that reflect a whole lot of light, and they're lighter inside. And these, by the way, are also very large. They're not as large as Tycho, but we're talking something like on the order of 10 miles across. So that's what it takes to light up craters on the moon, and any shadows on the moon, is a huge amount of backlight. And even that wouldn't have been enough. The photograph had to be overexposed. So this is a properly exposed photograph, and there is no huge amount of secondary light there. Or if it was on the moon, there would not have been any huge amount of backlight, and so the astronaut would have been black. Now, we might ask, didn't the Apollo scientists know how things should look on the moon so that they, would represent it that way? And the answer is possibly. Sometimes they may have simply overlooked things, made mistakes, but they may have known, actually. But that is not their goal. Reality was not their goal. They were producing a show. Aesthetics trumped accuracy. And for sure, propaganda was the aim, not truth. So the so-called astronauts were not actually on the moon. Where were they? They were on a moon set, and there are a few possibilities. Or not just possibilities, these are facilities that were used either for practice, training, or for hoaxing. This is a photograph of the moon, right? Craters on the moon. Actually, no. This is a field in Arizona. I was flabbergasted when I learned that myself. And this is the same field, but here you can see the tire tracks. Okay. And this is field number 2. This field right here. One of 2 fields in Cinder Lake, Arizona. This is written wrong. There's no S, and it's near Flagstaff, but the place is Cinder Lake. And this is field number 1. Again, this is field number 2. This is a close-up of field number 1. And here you see the trees in the background and bushes. Okay, definitely the Southwest American desert. And so here's the location, a little 12 miles actually northeast of Flagstaff, Arizona. There they are again. And here's an aerial view of field number 2. You can start to see some of the craters there. And what this is an ancient basalt field. It's from an ancient volcano. Here's a little closer up. And what they did was they cleaned up this field. Was already rather barren to begin with, probably, undoubtedly. But they cleaned it up even more, which I'll show you in a second. This is the material, the basalt. So they, in this film, in this little short film, this 9-minute film or so, that you can see on the internet, it shows how they made this field. And so they cleaned it up because they wouldn't do to have, bushes on a moon set, anything, terrestrial. And they blew up they blasted the craters literally out of the ground, like so. And this is the result, and it's pretty realistic. These are aerial photographs. And this is actually an aerial photograph of one of those fields. And this is an astronaut, I don't know which one, during training, running around these craters. And same here with something representing the moon buggy, the moon rover, the lunar rover. And you can visit these fields even today. And this gives you an idea of how large an area they had to play with. So some of those stage sets that we're going to see were rather large. We're not talking about literally a little stage set in a theater. We're talking about fields. Now, another moon set, so to speak, is the Langley Research Center in Hampton, Virginia, right here. And this place is like a university campus. And notice this structure right here. I'm going to get to it in a second. And it's so large they actually need a map to get around. And as it says here, there are over 200 facilities on the center. And this is the structure that I just pointed out. And it's called a gantry. And notice the cars down here. That gives you a feel for the scale of this thing. It's huge. And it's used to raise and lower objects, any object. But here we see the lunar module, a model of the lunar module being raised or lowered. And here a so-called astronaut onto a field that this one doesn't look very much like the moon, but you could certainly make it look like the moon. So they had that to play with. They also had huge moon globes, which they made very carefully, and wall charts that they illustrated to look, just like the moon. And here's one, a wall chart and a globe. And notice this rail track here. So they could use that to simulate approaching it or leaving the moon or orbiting the moon. And in this book, it's shown on a wider scale how you could use these facilities. And this is one of the reasons that so many of the moon photographs, alleged moon photographs taken from the spacecraft, are so funky and so in such poor quality. Because they weren't actually of the moon. They were of illustrations of the moon, and no matter how carefully you make them, they're not going to look quite real. And also, NASA wouldn't have wanted it to look, wouldn't have wanted very close-up views in perfect sharpness, because then the fakery would be even more obvious. This is what they were doing. They were photographing models of the moon, not the moon. Another moon set is in Mercury, Nevada, in or near Mercury, Nevada, which is part of the Nevada test site, actually. Right there. And this is all military restricted territory. That's Las Vegas right there. Use of deadly force authorized. These are photographs from Bill Casing's book, We Never Went to the Moon, which is an excellent book, one of the first books, actually the first major book on the Apollo moon landing hoax. And it shows photographs, as I said, of Mercury or around Mercury. There were numerous facilities there, top secret facilities. So any way you slice it, the NASA had moon sets. Literally where they staged the moon landings and carrying on the moon. The only question is whether that was just a training for going to the moon or if it was the entire thing. And clearly, as I will prove beyond doubt by the end of this presentation, this was all it was. They were never on the moon. Okay, more evidence. I already showed you 3 pieces of evidence from that iconic photograph that I began with, and here's more. As it says here on this photograph, every Apollo photo contains this unnatural separation line. Let us refer to it as the Kubrick horizontal. And what this is literally a line, a sharp line separating the foreground from the background wherever there's something in the background, like this fake mountain. Many of the photographs, in fact the majority, would have just a black sky, but wherever you have a distant background with things in it, you have this separation line, okay? And it is totally unreal, and it's ubiquitous. There's only one exception in all the hundreds, if not thousands of photographs I've seen, and I'll show you that in a second. But what you'll notice is the great amount of detail in the foreground, which is clearly real. You know, there's no question that this here is not totally made up. But what it is it's a stage set. It's a real stage set. This, however, is simply a projection on a screen. It's totally unreal, the background. And a number of, or at least one commentator said that every Apollo photograph seems to have 100 meters, what do you call it? A field of 100 meters in width, and then nothing, and then it drops off, and then, you know, things change. And that's what you see in all of these photographs here, is this stage set, which is limited. It's usually limited. As I said earlier, there are some photographs with a much larger field, but usually it's about this size, and then the fake mountains in the background, like so. There's the Kubrick horizontal. And many times it's so blatant that it's absurd, as if, you know, I mean, different coloring and everything, okay, and so sharp. Now this is the one exception that I mentioned, and here they succeeded. They obviously took more trouble, put more effort into it. They blended the fake background with the foreground, but still you have the detailed foreground and the totally washed out, bland, fake background. In real life, there is no such differentiation, certainly not such a sharp transition between foreground and background, at least not usually. Okay, and notice these people here to give you the scale of this scene. So here you have distant mountains, but they aren't totally washed out. You still have detail there. Why? You know, these guys had excellent cameras, so they took what should have been excellent photographs, but all their distant mountains are totally featureless, bland, mushy things. Okay. Anyway, so here the point is that there is no sharp distinction between foreground and background. Now, in these photographs from a panorama I took at my Nevada desert site, you'll see that eventually, as I pan, okay, we get to this point here where there is a sharp line. Okay, so it can happen in real life, but this is not the norm. This is in a specific place with a very particular geography. There's a dip beyond the end of this territory, this area here. Okay, there's a dip, and it's in one direction. It's not all around. This is more the norm. This is the norm here. You have no sharp distinction between foreground and background, and you have detail showing in the background objects. Where you do see the sharp contrast between foreground and background is in this filmmaking technique called front screen projection. Okay, there's the stage set and the actors, and then on a screen in the background is a larger a scene. This is a scene from Stanley Kubrick's 2001 A Space Odyssey, and this shows what's going on. There's a screen projected background and a foreground studio set. Okay, this is all there is in reality. A stage with actors in monkey suits actually, and the large screen for the projected background. And this is another scene from the same movie, and here the stage set is quite small in this particular scene, and then you have a larger background view which is totally imaginary, just projected. So here you have Apollo with the same sort of setup. An actor on a stage set, quite real, but only a stage set, not the surface of the moon, and then the projected screen background, or rather the projected background on the screen. And this illustration shows how it's done. You have a one-way mirror with the mirror on the opposite side. So here's the projector. It reflects the scene onto this large screen, specially reflective screen, and then the camera shoots through the glass, unreflected here, unreflective, I should say, unreflective, non-mirrored, okay, and this is what you see here. A real actor on a real stage set with a projected imaginary background. And this is a home setup showing in a little bit more clearly what's happening. You have the projector, the mirror, the special fabric screen, and the camera shooting through the glass. There's the mirror, the one-way mirror. More evidence of fakery. The infamous sea rock. In this scene, or photograph, there's something very, very strange, and it's right here. There's a sea on that rock. And stranger still, there's a sea on the ground right next to the rock. Okay? Perfectly formed seas. Now, to have one sea on just the rock or just the ground would be an extremely unlikely coincidence, that you have a perfectly formed Roman letter on a rock on an uninhabited moon, right? To have two of them together almost totally rules out any natural formation or any coincidence, which would be literally astronomical in its improbability. So what we're looking at here is really just a prop rock. And as this video said, the use of the letter C on film props is well known by Hollywood people and is used to show the center of the scene. Now, I couldn't actually confirm that, but certainly we're talking about prop rocks, which can be literally bought. I don't know where you would find them, but maybe not necessarily at your hardware store, but you can find them somewhere. And this one right here is about the right size for that previous scene that we saw. And you can put them anywhere you want, including on an Apollo moon set. More blatant evidence. Missing rover tracks. All right, here are rover tracks on the moon where the rover goes. Wherever the rover goes, it leaves tracks because it's very soft soil, very fine soil, supposedly on the moon. So here you have the tracks and what do you call it, footprints. And here you have tracks being laid by the lunar rover. Now, here's where the strangeness begins in relation to the rover tracks. There are none in this photograph. You can see footprints clearly, but there are no tracks between the tires, in front of the tires, behind the tires. How could that possibly be? This is the best resolution photograph, and you can clearly see that there are no tracks in front of or between behind the tires. Okay. How could that possibly be? It can't, because you have to drive the rover to wherever it is on the moon at any given time. The only remote possibility is if the, oh, and by the way, here's one more view. Actually, this is another photograph, and this is even more blatant. Here you have the footprints and more footprints, but no tracks. All right, as I was saying, the only remote possibility is if the astronauts literally lifted the rover and set it down. All right, but why on earth would they do that? First of all, it was never reported that the rover broke down. Now, it would be possible for the astronauts to lift it because in 1/6 gravity, the rover wouldn't be particularly heavy. But again, why on earth would they do that? First of all, they never reported the rover. They never reported having done that. They never reported the rover having broken down, and all of this would have been, well recorded if that had been done. So that really is that didn't happen. What really happened is pretty clear. The lunar rover was apparently lowered onto the stage set, probably from a crane, rather than driven to its location, as it would have had to be if it had been on the moon. And then the quote-unquote astronauts walked around it before it had been moved. So that was a mistake in the production. Another piece of evidence, and this one is, really damning. Large moving shadows. Here is one of the 2 astronauts on the surface of the moon at any given time. The 3rd astronaut was orbiting in the command module. It's actually the command/service module, but it's usually just called the command module. But anyway, so a crew of 3 Apollo astronauts each time, 2 on the surface and 1 orbiting. There's the 1 astronaut, and a little further away is the 2nd astronaut. And this is all being remotely filmed from a camera on the lunar rover. Now notice this fringe here. And here, these color fringes. That's called color banding. And that's a phenomenon in photography. It's not all that uncommon. And it occurs sometimes when objects and shadows move across the scene. And that's where that color is coming from. Just so that you know, so you're not confused. Now, watch what happens here as the camera films is focused on this distant astronaut. You have 2 shadows quickly passing in succession. Okay, I'll run it backwards. There's one, actually that was the second one, and there's the first. And with the color banding. All right, 2 shadows quickly pass across the entire scene, including that astronaut. And here it is in black and white. What could that possibly have been? There is nothing on the moon, living or not, that is moving. The only thing that would have been moving on the moon at that moment would have been those 2 astronauts. And as you can see, they're pretty still, okay? Because whatever caused those shadows happened very quickly, because you can see that the astronauts aren't even moving. They're pretty much frozen. All right. There cannot be such shadows on the moon, since the 2 astronauts are the only moving objects there. There is nothing, quote unquote, flying in the moon's sky, except the orbiting command module, which, being so high and small across the face of the sun, would not cast a shadow at all, much less appear and in these shapes. Something clearly passed across the moon set's floodlight. And that's because they were in a studio on a moon set, not on the moon. And here is a real killer. We're running into, there are a lot of killers here. This one pretty much slays the Apollo mission. This is this one is going to be specifically Apollo 11. Okay, before we get into that though, let's look at some footage of spacecraft orbiting planets. Okay, this is the shuttles orbiting Earth. Okay, planetary objects. And these are 5-second intervals for each of these frames from this video. And you can see that things move very quickly. Okay, I should have actually done that more smoothly. Things move very quickly out of the field of view, and certainly out of the center of the field of view. Nothing stays put, okay? Because any spacecraft orbiting Earth or the Moon would be moving literally thousands of miles an hour. It's not hanging around. This is allegedly a spacecraft, the Selene. I think it's the Selene Moon Explorer or whatever it's called, orbiting the Moon. Now, I have serious doubts about the authenticity of this. This terrain, I think, is fake. But certainly the orbital motion is realistic. Okay, so let's go through that. Now watch that crater, big crater, coming from the top. Okay, I'll run through it one more time. Again, things are moving quickly out of the field of view. Even within the field of view, they're moving very quickly. Okay. And then finally, here's an Apollo 10. Here's footage from Apollo 10, which preceded Apollo 11. And here things move out of the field literally in 2 or 3 frames. Within 3 frames, things are gone. You can hardly even keep track of them. All right, we're talking about just seconds, just a few seconds in any given in the field of view for a particular object. Now this is a footage. This is footage of. This is supposed to be live footage of Apollo 11 as it was starting to orbit the Moon when it first arrived there. And so I'll read this. A live broadcast of the Apollo 11 spacecraft allegedly orbiting the Moon for the first time. The craft's movement shown here is nothing like the completely smooth, unidirectional motion of the craft in the preceding videos, where things on the ground very quickly moved out of view. Imagine a rifle bullet with a tiny camera on it. And as a matter of fact, the Apollo 11 spacecraft was supposedly orbiting the Moon at twice the speed of a rifle bullet. And here's Frank Reynolds and his sidekick analyzing and commentating on what's going on. And I'm going to run through just 3 frames quickly. And these, like the others, are all 5-second intervals to show you a couple things. First of all, look at the quality of this video. It's ridiculous. Why couldn't they show you clear pictures, something like these from the lunar orbiter spacecraft, or one of the lunar orbiters, which orbited the Moon and took photographs before Apollo. Okay. Secondly, I want to orient you. This is Haldane crater here, and this is Schubert and Bach. Okay, these are going to be the craters we're going to focus on at first. Haldane, Schubert, and Bach. Okay, so now let's watch what happens. There's Haldane, a very unique-looking crater, and here's the larger scene. There's Haldane, Schubert, and Bach, and then they're going to move from top to bottom here, which is actually from east to west. Okay. All right. Finally, let's go through the scene. Now notice how erratic the motion is. They're zooming in and out, so that confuses things even more. But what I want to really point out is how long those 2 craters, Schubert and Bach, these 2 craters here, were in this field of view. They were in that field of view for 3 minutes. Okay, I'll speed up to get to the beginning again, and we'll see. I'll show you again. Okay, Here's the first frame where Schubert and Bach are clearly in the scene, in the field of view. Okay, the field of view is simply the distance across this window that they're looking through. Okay, so there's Schubert and Bach at the bottom, and they're going to stay there. Actually, they're going to skip over to Haldane, going in the wrong direction, by the way. But when they come back down, they're still over Schubert and Bach. There's Schubert and Bach near the top there. There it is in the middle again, going back to the top. Finally, they leave Schubert and Bach. And this is an impossibility because they couldn't have hung around over those two craters for 3 minutes. Here's Schubert and Bach, and together they're 60 miles in length from both of them together are 60 miles in length. The field of view is only twice that distance, which is 120 miles. Schubert and Bach are 60 miles, okay? And the orbital speed is 1 mile per second, okay? 3,600 miles per hour, which works out to 1 mile per second. So that field of view that they were looking at should have and would have been covered in 120 seconds, okay, 2 minutes. Instead, and you can go back and look at the times, but I've already done that, they covered it in 180 seconds. They took a full minute too long to cover that ground. And compare the length of time for any given object in the same field of view for the Space Shuttle, 30 seconds, Selene, 20 seconds, Apollo 10, 10 seconds. Okay, so here's an illustration of what's happening. The field of view is 120 miles. Okay, we can measure that. I did measure that. So in and because the speed is 1 mile per second, in 120 seconds, they've gone 120 miles, and they're looking at an entirely new field of view with an entirely new set of objects. There should be nothing if this is the second field of view, there would be nothing in it. They would have been from the first field of view, I'm sorry. Okay, an entirely new field of view. They went not only 120 seconds, they went 180 seconds. They supposedly would have moved 180 miles, all right? So they would have left whatever was here at first in the field of view they would have left it a long time ago, all right? Schubert and Bach would no longer be in the field of view after 120 seconds, much less 180 seconds. The spacecraft stays over crater Schubert and Bach, moving only very gradually for 3 minutes, an impossibility given what should be its extremely fast and constant orbital motion. In reality, the two craters would have disappeared from the field of view much sooner, after 2 minutes. Continuing, the spacecraft then sits completely motionless, an even more flagrant impossibility, directly over another crater, starting at this time here, 1 hour, 13 minutes, 30 seconds, for 1.5 minutes. Overall, the spacecraft's motion is ridiculously erratic, both in speed and direction. Clearly not orbital motion at all. So we're going to continue, okay? And now we're going to be over these 3 craters here, or this set of craters. Okay, that's going to be what's prominent in the field now. All right, so here we were, or they were, Schubert and Bach were at the bottom of the field of view. They moved to the top of the field of view because they're moving, now the spacecraft is over here, and now it's going to be over these 3 craters, and it's going to continue moving west. So watch what happens here. They sit over that crater for a while. Now watch this crater right here. Okay, it's going to move into the center of the field of view, and watch what happens after that. There it is in the center of the field of view. It stays in the center of the field of view for 1.5 minutes. It doesn't move at all. In other words, the Apollo 11 spacecraft is not moving until finally they leave. They hovered over that crater, which is a complete impossibility because there is no hovering in orbit. It's like a rock flying around the moon. It's literally, that's what an orbit is. Okay, and they had no technology to be hovering over the moon. They were showing us, what they were showing us was filming of a model. They were not orbiting the moon, period. Okay, moving on to the moon environment. And first we want to consider that the moon sits in an almost perfect vacuum. And I want to make this note. One of the keys to pulling off this deception by NASA is that the moon is a vastly distant alien place, totally inaccessible to non-astronauts, the perfect place about which to concoct a fairy tale. And for us, this is the key to unraveling the deception. To test NASA's story, we have to start not with the bogus material they provide us, but with our known Earth experience, as well as what we already know about the moon from solid scientific and astronomical knowledge independent of Apollo. So we're going to start with Earth. That's going to be our ground, so we know what reality is like. And this is a four-wheel drive car, Subaru, in fact. And what this video shows is, I'm going to just show you frames from the video, is rocks being sprayed in an arc away from the tire. And the interesting thing is that the rocks trace a shallow arc straight back. And in the video, especially, but also here, you can see individual rocks like that one right there, okay, move back in this shallow arc. And not many rocks get above the height of this tire, or certainly not this quarter panel. A few end up, up around here, but that's because they collide with each other. But otherwise, they almost all go straight back. And this rear tire, as you can see there, is shooting rocks as well, independently of the front tire, and that's how they go. Okay, so the arc that they were tracing is similar to this one here, maybe a little higher. And these are all parabolic arcs. The only difference is the amplitude, the height and the distance. So I'll just read this here. Projectile motion is a form of motion experienced by an object or particle, in other words a projectile, that is thrown near the Earth's surface and moves along a curved path under the action of gravity only. In particular, the effects of air resistance are assumed to be negligible. This curved path was shown by Galileo to be a parabola. The study of such motions is called ballistics, and such a trajectory is a ballistic trajectory. And here is this trajectory traced by this water, this stream of water. And the typical, or I should say the prototypical example is a cannonball, because a cannonball is so massive that the air resistance is going to be negligible, because what we're talking about is the relative mass of the cannonball and the air. There's a large difference. So this is the parabolic trajectory that we're talking about. Now watch what happens with the sand here on this beach and with this dune buggy, the sand particles as they're shot from under this tire here. This is something completely different. They are not tracing paths, trajectories straight back like the rocks did. And that's because the sand is much lighter. So relative to the air, they have much less mass. And therefore they encounter very significant air resistance. And they bunch up here. The lead sand particles are slowed down by the air. They run into a wall of air all around the tire. And then the particles following the lead ones collide with them and bunch up. Okay? And that's why you get this concentration. But they still have energy, kinetic energy. And so they hit each other, and they have to go somewhere. They go up. Okay? And this is, in fact, is a classic, or both of these are classic rooster tails. These guys that do these things, play around with these dune buggies and such, that's what they call them, rooster tails. Here you see, as this dune buggy moves, that it shoots up numerous rooster tails, vertical columns of sand. And the sand sits up in the air, in dust clouds, and then just settles gradually down, back, almost straight back down. In this video, you see even more closely what happens right from the beginning. The sand particles run into literally a wall of air. It's like a viscous fluid of air around them, around the tire. And so they don't go straight back at all. They form these classic rooster tails vertically, like so. And here you see the multiple columns of sand, in this case with this motorcycle, and the sand dissipates suspended in the air, and then settles gradually straight back down, pretty much, like so. So these trajectories are very different. They're trajectories with linear air resistance. They're not parabolic trajectories. They're not symmetrical at all. Not like that. Okay, so let's compare this lunar rover on the moon with what we just saw with that dune buggy on Earth. Okay, this should be very different, of course, because they're in a vacuum. And by the way, this particular scene is from Apollo 16. They were racing around and showing off what they could do with the lunar rover. So here we go, and what you see is nothing more or less than the exact same phenomenon. Okay, it's not, the parameters again are gonna be different. The height of the particles, the exact quote unquote specification, so to speak, but the overall phenomenon is the same. A rooster tail, a vertical column of sand, suspended. It becomes suspended in the air and settles down very gradually. It is not, these particles are not exhibiting shallow trajectories, parabolic arcs at all. And here you see the classic arc of a forming rooster tail, and there it goes, gets bigger, and then settles down. The dust settles down gradually. And here's the multiple columns of sand in multiple rooster tails. And there's another example of a nice big rooster tail. It's the exact same general phenomenon of how sand particles, because they're in sand, fine sand, how sand particles behave in an atmosphere, okay, in air. They were not on the moon. The behavior of the sand or dust in the case of the lunar rover is essentially identical to that of the dune buggy on Earth, complete with prominent vertical rooster tails. But this would not be so if the lunar rover were really on the moon. The particles would, despite their low mass, instead shoot straight back in low parabolic arcs like the rocks of the four-wheel drive car, since they are launched from a similarly low point on the tires. In a vacuum, the mass of a projectile is irrelevant to the basic shape of its trajectory. All projectiles move in symmetrical parabolic arcs, since there is no air to offer resistance to their motion and cause their trajectories to deviate in any way. Without question, the lunar rover, quote unquote, is being driven on Earth. Okay, moving on to gravity. The Earth is much larger than the moon. This is something that probably a lot of people don't quite recognize, because we look up in the sky and we see a large moon, or what we imagine is a very large moon, especially near the horizon. And also in the sky, it's the moon is the same size as the sun, which we know is huge. So we imagine that the Earth would look more or less the same, but in fact the Earth would appear much larger, because in fact the Earth is much larger than the moon. And the mass difference is huge. The Earth is 81 times more massive than the moon, or in other words, the moon is only 1.2% of the mass of the Earth. And this translates into a moon gravity of only 1/6 that of the Earth. And here is the difference in size, graphically illustrated. It's like a basketball to a tennis ball. But whereas a basketball is less dense than a tennis ball, the Earth is actually more dense than the Moon, because the Earth has a solid iron core, whereas the Moon is just rock throughout. So the average person on Earth, especially a young, fit person, can easily jump 1.5 feet or 2 straight up on the Earth, like so. And here's this chart which shows that the average man, or the average jump of an average man, is 1.5 feet. Okay? And professional athletes can jump quite a lot higher than that. In fact, they can jump over 3 feet straight up. Now here's an average man. We're going to take this person as an average man, probably about 180 pounds. This is that actor, by the way. I forget his name. He did James Bond movies, I believe. But anyway, now how much would he weigh on the Moon? If he weighs 180 pounds on Earth, he would weigh 30 pounds on the Moon, 1/6 of that. And that's equivalent to a 5-year-old boy. Okay? So he weighs 30 pounds on the Moon, but he has the body of a 180-pound person, a strong man. So he would be able to jump 6 times as high, because he's only carrying 1/6 the weight he would carry on Earth. So 6 times the 1.5 feet that he could jump on Earth would be 9 feet. He would be able to jump 9 feet up in the air. Not in the air, the Moon has no air, but straight up, okay? Now, how high would an astronaut be able to jump on the Moon carrying a heavy backpack? Okay, now this backpack weighs about 120 pounds. So now a 180-pound man weighs 300 pounds, and all the astronauts were roughly average height and weight. So you're carrying 300 pounds, but it only weighs on the Moon 50 pounds, because you divide 300 by 6, which is the weight of an average 7-year-old boy. So you have a 180-pound man, a strong man, carrying only 50 pounds. He should be able to jump about 4 times what he jumps on Earth. Okay? So he should be able to jump over roughly 6 feet. He should be able to jump like this. And by the way, that photograph that I showed you, this whole scene, this whole sequence, is from John Young's famous jump salute in Apollo 16. Okay, so he was demonstrating either, maybe not explicitly, but implicitly, the low gravity on the Moon. But he failed entirely, because this is how high he should have been able to jump. Okay, it should have been very dramatic, completely unmistakable that he was in low gravity. Now watch the actual jump. That's as high as he got. He jumped a normal 1.5 feet. In other words, he was on Earth. He was definitely not on the Moon, because he definitely would have jumped much higher on the Moon. In Wernher von Braun's book, Conquest of the Moon, which, by the way, is a much more realistic depiction of what a real moon voyage would be like than Apollo, this is what he said. Our movements are restricted by the cumbersome suits, yet we will feel light. The Moon's gravity is 1/6 that of the Earth, so a 180-pound man weighs only 30 pounds. We will wear weighted shoes to help pin us down. They would need to have weights to hold them down, otherwise they would go too far and too high. But look at the jumps on the Earth. Here's another one. The guy jumps a normal height. Did I say Earth? On the Moon, yeah. He's supposed to be on the Moon, okay? But he jumps the height of what the same height as he would on Earth, more or less. That is not an abnormally high jump by any stretch. And you can see the same thing you see the same thing when they're walking and running as well. So here you see this astronaut hopping along. They do this little hop to make it look a little bit unusual, but clearly, and I'll run it backwards, or run it back and we can see it again. His feet do not get up high. They are just inches above the ground, okay, which would not be the case on the moon. It is the case on Earth, but it would not be the case on the moon. So here's what Gerard Wisniewski says, explaining what's going on. With less gravity on the moon, the strides would above all gain in height and length, and they do not. The strides are slower without becoming higher or longer. This would suggest that the photos were shown in slow motion. When speeded up, they immediately begin to look natural, in other words, earthly. So in some of these videos, like this one here, What Happened on the Moon, they actually go through the famous jump salute and other sequences, but they show them at normal speed. And they speed up the obviously slowed down moon film, and then they run that, and it appears completely normal. I'm not going to show you the video sequence, but the jumps become completely normal, as do the runs. Okay, in this video here, you can see these guys running after they've speeded up the film, and they look perfectly normal. And this is what must have been done, because if they had been on the moon and you had speeded up the footage of them on the moon, it would have been even more abnormal. Okay, at normal speed on the moon, they would have been jumping way higher and way farther than on Earth. And if you speeded it up, they would have looked like Superman. They would have looked like they were flying above the surface of the moon. Instead, when you speeded it up, they looked like they were on Earth completely. So slow motion was the key. It gave them a bouncy, floaty feel, or at least it looked that way. And this was the key to the illusion. So this is the kind of thing that we saw on TV. And I'm just going to show frames from the film. It looks slow and floaty. Okay, this is what it would look like at normal speed. Okay, it would look completely like a normal jump. That's the same basic sequence, except that I used a whole lot of frames in this one. Okay, and then I used a few frames to simulate simply a faster speed in this one. Okay, that's all it was. It was just playing with the speed of the film. Neither of these jumps is an abnormal jump at all. It's an earthly jump. All indications are that these astronauts, these so-called astronauts, were in Earth gravity, not moon gravity. And they had a few other alleged demonstrations of low gravity. At one point, they hit a golf ball, supposedly, except that they didn't show where the golf ball went because the camera was fixed on the lunar rover and didn't follow the ball. The astronauts said, "Oh, it went miles and miles," but we didn't see that. They did the drop of a hammer and a feather, one in each hand, but that demonstration has been reproduced on Earth. It depends on the density of the feather. I did that experiment myself. If you have a fluffy feather, it'll drop slower than a hammer. If you get a dense feather, it'll drop the same speed as a hammer. And who knows that they didn't use a plastic feather, for all we know. Okay, so that doesn't demonstrate anything. And then at another point, they threw a hammer. This small hammer that they used for their geological work. They threw that, or one of the astronauts threw that, but from all appearances, it looked like a 30 to 50 meter throw, which would have been perfectly normal in Earth gravity. It did not go hundreds of meters, which is what we would have expected on the moon. So the point is that they definitely were not on the moon. They were not in moon gravity. Radiation. These are aurorae. That's plural for aurora, also known as northern lights, except that they also occur at the South Pole. And they're very beautiful. If you've ever seen a good display, you won't forget it. And what it is energetic particles, radioactive particles, coming from the sun and hitting the Earth's atmosphere. So they demonstrate that radiation, space radiation, is a reality. There's no question whatsoever about it. And the first confirmation of this was in 1958, I believe, when the Explorer satellite went up, this satellite here, and it carried a Geiger counter. I believe that's how you pronounce that, Geiger counter, which measures radiation. And the radiation was so strong that it knocked out the counter. The gauge went off scale. And Ernie Ray, one of the scientists involved with this Explorer launch, said, "My God, space is radioactive." And indeed it is. So there are three types of space radiation. There are particles trapped in Earth's magnetic field, there's solar particle events, and there's galactic cosmic rays. And this is a more colorful illustration of this. These are the galactic rays. This is the Van Allen belts, which I'll explain in a second. And this is the solar particles coming from the sun. So, galactic cosmic radiation. Distant supernova explosions are thought to be the source of these high-energy ions. They travel across the galaxy at close to the speed of light and can easily pass through the walls of a spaceship. With current technology, at least, they cannot be shielded against. Trapped radiation. Earth's magnetic field can trap charged particles from the solar wind. They become confined to the Van Allen belts, two donut-shaped magnetic rings encircling the planet. This type of radiation does not pose a threat unless astronauts travel through the magnetic field, but they in fact have to. Solar energetic particles. These high-energy particles are released by the sun during periods of intense activity known as solar particle events. Although these events are hard to predict, astronauts and vulnerable equipment can be protected from this form of radiation using shielding materials. This kind of shielding, though, is extremely massive, or would be massive. That's why it's never used. So this whole business of protecting astronauts with shielding material is completely theoretical. In practice, it's impossible. And Apollo had no such shielding. So this is the Van Allen belts. There's an inner belt close to the Earth. Okay, that one right there. And the outer belt. Now, another indication of the reality of the Van Allen belts and space radiation in general is that we actually encounter it. Earth satellites actually encounter it at the South Atlantic anomaly, this point right here. And the reason is that the Van Allen belts are asymmetrically distributed around the Earth, and that's because the magnetic axis is off center. Okay, it's not the same as the rotational axis. So because of that, one of the spots of the inner Van Allen belt comes very close to the Earth. In fact, it's called the South Atlantic anomaly because it's right there in the South Atlantic and over Brazil. And this is a more dramatic illustration of that. The closest radiation belt to Earth roams above South America. It is called the South Atlantic anomaly and gives off high levels of radiation that has been known to destroy satellites. And these are some of the satellites it's destroyed: the Terra satellite, the Nozomi satellite, the CSAT satellite, and the Yamal satellite. Okay, and it's done other damage to other space vehicles as well. Now, moving on to the solar particles. This is a prominence. Okay, this kind of thing happens during the sun's magnetic storms, and these storms happen on a cycle, an 11-year cycle. They intensify over a period of 11 years. Now, this, as I said, is just a prominence. That's not the actual particles that fly all the way to the Earth. You can't see those. Those are atomic sized particles. And this is a graphic illustration of the size of these storms. This is the Earth to scale. Okay, the storms themselves are much larger than the Earth. So a huge number of particles travel from the sun to the Earth. However, we are protected from these solar particles by our magnetosphere. Okay, this is practically a what do you call it? A force field, literally, that shields us from the oncoming dangerous particles. Now, the Van Allen belts are much closer to the Earth, and they don't shield us, but we aren't bothered by them as long as we don't travel through them. So we're protected in this cocoon of ours. And as I said, the storms follow a cycle. It's also known as the sunspot cycle, or the solar cycle. And it's an 11-year cycle, and one of those peaks was right at the Apollo missions, the Apollo moon landing missions. So the astronauts would have been, if they had actually gone, would have been subjected to thousands of solar flares. Here are the numbers here. During 1968, or rather 69, 70, 71, 72, thousands of solar flares. Now the flares vary in intensity, but some of them are and would have been deadly to the astronauts. They received on average about 150 flares, or they experienced an average of 150 flares each on each mission. As again, some of those would have been deadly for sure. As John Malden says, and I'm going to quote from a few books here, and notice the dates. Okay, this is all long after Apollo. So this problem of radiation persists. Apollo did not solve it. So John Malden says, cosmic particles are dangerous and require at least 2 meters of solid shielding around all living organisms. Solar flares can give doses of hundreds to thousands of rem over a few hours. Such doses are fatal and millions of times greater than the permitted dose. Neil Commons says, you will face much, much more radiation in space than you do on Earth. Galactic cosmic rays will continually bombard your body and cause cellular damage. Solar energetic particles cause serious illness and death. Van Allen belt particles cause irreparable damage to living tissue. No reasonable quantity of known material will stop all these rays. This person, Leon T. Miroshnichenko, says solar storm shelters, that is, special thick-walled rooms, will be necessary both on the transit spacecraft and on the planet's surface. But the design of radiation shielding for a spacecraft is very difficult. Now, and the more realistic accounts of a future voyage outside of Earth's protective cocoon all talk about these storm shelters. But they would be, this is a vast understatement. They wouldn't be just very difficult. With no technology, they are impossible because they would require, they would be very massive, and you wouldn't be able to get a ship off the surface of the Earth with the required thick walls of a storm shelter. Yet that's what would be necessary both on the bodies that they would visit, like the moon, as well as in transit. So the whole thing, with our technology, space travel is an impossibility, period. Now, von Braun, more realistically, what he says that his astronauts would do, not his astronauts, of course, but what astronauts would do when they get to the moon is immediately get into shelter, okay, into a large crevice where they would be able to build their bases, and they would be protected both from the radiation as well as micrometeorites. Compare that practical, sensible practice with the Apollo astronauts who saunter around, prance around the moon without a care and completely exposed to both deadly radiation and deadly micrometeorites. Never was any kind of problem reported by the Apollo astronauts. Another indication of the unreality of Apollo is that the Soviets were always ahead in the space race. And here's a long list of firsts. They had the first satellite, the first spacecraft to the moon, okay, the first man in space, of course, first spacewalk, etc., etc., etc. So why didn't they reach the moon before the Americans? In 1963, Soviet space scientists told the famous British astronomer Bernard Lovell, in connection with their lack of plans for a lunar landing, that they, quote, could see no immediate way of protecting cosmonauts from the lethal effects of solar radiation. Viktor Bazykhin, a Soviet astronomer, says the information obtained with the aid of Sputniks, rockets, and balloon probes has proved beyond all doubt that radiation is the chief obstacle to penetration of cosmic space. The National Research Council, okay, in 2008, this is what they wrote: exposure to the space radiation environment outside of the protective magnetic field of Earth presents a risk with which humans have limited practical experience. What on earth are they talking about? What about Apollo? There was hardly any mention of it. Having a vexing discussion about the conundrum of space radiation today is like worrying in the 16th century about how to sail across the ocean to another continent when the voyage had already been completed numerous times and mastered by Columbus and others in the 15th century. It's absurd. If Apollo had been real, the radiation issue would have had to be resolved then. The problem still exists now because it was never tackled, and this, of course, is because Apollo was a fairy tale. Here are some damages to the body caused by space radiation. Cataracts and damage to the eye, increased cancer risk, damage to the circulatory system. I'm not going to go through all of them, and this isn't even a complete list here. Skin damage, damage to muscles, cartilage, etc., etc. Okay, and why is this? It's very simple, because radiation kills cells. All right, cell death, dead cells, and it breaks down the body. Yet, these 12 astronauts are supposed to have walked on the moon, and 12 others are supposed to have made the trip, and even though they didn't walk on the moon, they would have been subjected to about the same amount of radiation, and all of them lived normal lives without any effects of radiation either during the trip or immediately afterward. No radiation illness or anything of the sort. In fact, they all have lived, almost all have lived long and healthy lives. The average age at this point in time is 80, and more than half of them are still alive. So there's no indication whatsoever that they had any encounter with any space radiation, and that's because they didn't go anywhere. In fact, we can't leave our protective magnetosphere cocoon. If we do, we're fried with our current technology. Okay, now we're going to look at a topic, a subtopic of this Apollo hoax that few investigators, if any, have looked at carefully. And that is the surface of the moon as depicted in the Apollo photographs compared to how we know it is and has to be. And we're going to start first on Earth with meteor showers. These are periodic bombardments of the Earth by small particles. And they occur, this phenomenon occurs when the Earth in its orbit around the Sun plows through the old orbits of comets, mostly comets, a couple of asteroids as well. And in these old comet orbits, and when I say old, I don't mean the comet itself is old, but the debris from the comet has been sitting here for as long as the comet has been going around. Okay, so the Earth plows through these comet trails where there's all this debris, and it's not just dust. I like this depiction because it gives you an idea of the number of particles, which is a vast number, but it's not dust at all, at least not mostly. The particles can be are pebble size mostly, and they get up to the size of baseballs, softballs, and that kind of size. They're not usually very large, but they can be sizable. Now, there are about a dozen regular periodic meteor showers, yearly meteor showers that is. And in tables like these, we are told the length of the shower and most critically the number of particles that we can expect to see hitting the Earth's atmosphere. And this is the zenithal hourly rate. And this is one such. And so as the Earth goes through the path of the comet, the number of particles increases, that we hit increases to a peak. All right, but that peak is what's shown here. These tables show the peak, but of course we're not always at that peak. So to get an idea of the number of meteorites that we're encountering, we're going to take half of that peak, and we're going to take half of this duration of the shower to get an estimate of the number of particles that we're talking about. But before I do that calculation, I want to make this important note. The meteor counts given here are used because they are readily available, not because they are definitive. In fact, they are undoubtedly a vast underestimate of all the meteorites that strike the Earth and the Moon. In the case of meteor showers, this is because the zenithal hourly rate represents only the number of meteors a given observer can be expected to see from any one location on Earth, not a literal count of all the individual meteorites striking the entire planet at any given time, which of course would be an incomparably larger figure. In the case of bolides, which I'll describe in a minute, it cannot by any means be assumed that the instruments used to record the bolide strikes actually succeeded in detecting all the strikes in the given period. They most probably did not. Okay, so here we go with this calculation. As I said, we're going to take half the days. We're going to use that table that we just saw, and we're going to take half the days and half of the ZHR, and we just multiply, simple arithmetic, and we get this total for the year. Okay, about 67,000 meteorites from the meteor showers. But that doesn't include the sporadic or background meteorites, okay, which occur regardless of the showers. There's a constant bombardment independent of the showers, which is roughly 5 meteorites per hour. So you multiply that by 24 hours, 365 days a year, and you get this figure. So the total altogether comes out to 111,000 and plus, okay, meteorite strikes from meteor showers per year. Now, the life of the moon is over 4 billion years, and I'll explain that a little better in a second. But what we're looking at, what we're seeking to find is the number of meteorite strikes that the moon has suffered. Now, the moon and the Earth obviously orbit the sun together, so we can get a good idea of that number from the meteor strikes that we observe on Earth. Okay, going now to the moon. As we said, 445 quadrillion strikes over 4 billion years. Okay, and the surface area of the moon is 38 quadrillion square meters. So you divide that number by that number, and you get 12 meteorite strikes per square meter of the moon's surface. Now, as I said earlier, most of the meteorites are the size of large grains of sand to pebbles, but some of them are about the size of a baseball or a softball or even larger. A softball-sized meteorite would be about 4 inches wide, and when those objects strike, when any object strikes the moon, it leaves a crater about 10 times the size of the object itself, diameter-wise. So a 4-inch diameter meteorite, which would leave a crater about 40 inches in diameter, which would cover the entire square meter that we're talking about here. Okay, so these figures already tell us that the moon is completely covered by craters, at least small craters. This is a post-production editorial note. I made a couple of mistakes in my calculations in the original video. So now this number is different, this number is different, this one, and this number is slightly larger. The yearly total for the meteorites from the meteor showers. More significantly, and also this number is different, but as I was saying, more significantly, I skipped trillions and went straight to quadrillions for some strange reason, which I could explain, but you don't want to hear my excuses. So this is 474 trillion. It's not quadrillion. And here we have trillions and trillions, not quadrillions. Okay, but luckily for me, since I made the same mistake in both places here, the division is turns out to be roughly the same, or the figure from the division turns out to be roughly the same, 12 meteorite strikes per square meter. I might as well take this opportunity to make something else more clear than I did before, and that is that the moon, being smaller than the Earth, obviously gets hit by fewer meteorites because it presents a smaller surface to the oncoming shower that hits both the Earth and the moon. Now these figures are all based on the Earth, which again is much larger. So they aren't strictly accurate for the moon. However, as I did explain, all of these figures are vast underestimates even for the Earth. So that would tend to compensate for the fact that the moon is smaller and gets hit by fewer meteorites. In any case, all of these calculations and all these figures are just aimed at getting a broad idea, a ballpark figure for how many meteorite strikes we can expect the moon to receive. There's no pretense of exactitude here. Now, so far we've been talking about meteor showers, and that's not even half the story, because there are bolides, which are large objects. They're in fact small asteroids. And now we're talking about meters in size, okay, up to many meters in size. This is the largest bolide strike of the Earth in the past 100 years. It's the Chelyabinsk meteor over Russia. And this is such a cool video that I'm going to show it to you. And now this meteorite came in, and it was detected through numerous, what do you call them, dash cams in this case, and other photographic records. And here it comes. And there it goes. Now I'll run through it again a little slower because it's so cool. It takes a while to get over this point, and then it explodes right there. Okay, and then the remaining fragments continue. That's the main one, and then there are trailing ones, and the trailing ones are burning, and the main one keeps on going. As I said, there were a number of recordings of this strike, which is one of the greatest, phenomena, astronomical phenomena we've seen. This occurred in 2015. Now, there was hardly any damage to the Earth's surface from this meteorite, which was about 20 meters in diameter. It broke up. As we saw, it exploded. And a number of chunks hit the Earth, but this was the largest right here. It just hit a lake and went down to the bottom, and they recovered a couple of the largest pieces. This was the largest piece here. I think that weighs about over 1,000 pounds, something like that. But the important point for our purposes is that this bolide didn't even damage the Earth significantly. It caused a lot of explosions, that windows bursting and that kind of thing. and so it did injure a number of people, but it didn't leave a lasting crater or anything like that. So this is a very significant point. The fate of A, meteors, and B, craters on Earth. Because of our thick atmosphere, most meteors are destroyed or at least drastically slowed down. Therefore, few craters result. Surface alteration, that is erosion and geological activity. Because of this, on Earth, craters are erased relatively quickly. We're talking about plate tectonics, volcanism, erosion from wind and rain, water, all that kind of thing. Okay. Now, the fate of A, meteors, and B, craters on the moon. Because the moon has no atmosphere, all meteorites hit at full speed and with full force, and all meteorites produce craters. There's no weather or geological activity on the moon, therefore, there's no significant erosion. Craters remain forever. These are the bolides that hit Earth during this period, a 20-year period, as recorded by U.S. military installations of some kind. The articles didn't explain. But anyway, the number is what's significant here. And these are bolides in the 1 to 20 meter diameter range. Okay, 556 over that 20-year period. So you multiply these two figures and you get about 110 billion meteorite strikes, bolide strikes that is, in 4 billion years. And you divide that figure by the by the surface area of the moon, which we saw earlier. Okay, and you get 2,900 strikes per square kilometer. Now, let's take the average impactor, the average bolide, as 4 meters in diameter. As I said, by definition, the bolides that we're dealing with are 1 to 20 meters in diameter. And of course, they can be larger than that. But anyway, conservatively, we take a 4-meter impactor as the average. That gives us a 40-meter crater. And that's this area right here. And you multiply that by 2,900. And you get a surface area of 3,600,000 square meters. Okay, but we're talking about the number of strikes per square meter, per square kilometer. All right, so we get this figure and a square for the size of the craters collectively on the surface of the moon. And that's over each square kilometer, which is only 1 million square meters. So 3,600,000 divided by 1 million is 3.6 square kilometers of crater area per square kilometer of moon surface. In other words, the moon is covered many times over by craters, by not only the meteor shower craters that we saw earlier, which would be mostly small craters, but these larger craters as well. The moon is literally covered by craters. Many times over, as a matter of fact. And scientists know this, astronomers know this about with regard to the highlands, okay, where you see in photographs all these craters. Now, what I'm going to argue is that the Maria are also, the lowlands are also covered by innumerable craters, okay? So to think that the Maria are smooth and craterless is actually a misconception. We get the best idea of how blasted the moon is by craters when we look at the far side of the moon, the side that's always facing away from the Earth. It is totally covered in craters everywhere, and craters on top of craters, okay? That shows you how blasted the moon is by meteorites. Now, the only reason that there are Maria without all those large craters is that after 500 million years of the life of the moon, also the life of the solar system, during that first 500 million years, there was this bombardment of the moon and all the solar system bodies by large impactors, by planetesimals, okay, small asteroids, planetesimals. And that went on for about 500 million years. And then all of those bodies flying around collected, they aggregated into the planets and moons that we know today. All right, so that bombardment ended after 500 million years. But toward the end of it, those large planetesimals pierced the moon's near side, and that's because the moon's near side has a thinner crust than the far side. They didn't pierce the far side crust for reasons that I don't want to explain. The near side of the moon has a thinner crust. Okay, so lava, molten lava, rose out of the interior and covered these areas here, which is the Maria. All right. However, ever since then, and this is where the 4 billion years comes in, the moon has been bombarded by meteorites, as we saw, both meteor shower meteorites and bolides as well, just like the Earth, except that all the craters remain on the moon. So it's a misconception to think that the Maria regions are more or less free of craters. First of all, we can see that there are a number of craters in them, but we'll see more. Okay, and the moon has been bombarded ever since then, as we see in recent photographic and video records. This is a 1953 photograph of a meteorite strike. It was estimated that the impactor was 20 meters in diameter, and it left what is estimated to be a 200 meter wide crater that was found. This is a video from 2013, I believe, that shows a meteorite strike. I'll show that again. That's a meteorite strike, caught on video. Here's another video, and for some strange reason, this institution had to paste these large logos all over the moon, but this is the moon, okay, and this is where the strike is going to be, and there it is. Okay, so this is also 2013. These two were from 2013. So the bombardment of the moon has gone on unimpeded ever since that late heavy bombardment, and that includes, of course, the Maria as well. So before we look at the Maria more specifically, let's look at some of these famous craters on the moon. This is the most famous of all, Tycho. It has this this what do you call ejecta blanket. Okay, it's called an ejecta blanket. This material that was blasted out of Tycho when that meteorite struck. It also has crater rays. These things here, okay, which go as far as here as we can as far as we can tell. Okay, literally hundreds and thousands of miles across the surface of the moon. And this is what one astronomer said about Tycho. As you gaze at the ray system, try to appreciate the force behind an impact that would scatter boulders more than 1,000 miles across the surface of the moon. It is popularly assumed that these rays have the texture of face powder and that an astronaut would have difficulty detecting them if he were standing in the middle. Such is not the case. The brighter rays are made up of ejected rubble that consists of crushed rock and boulders that are up to a couple of feet in diameter. Large rays are commonly several feet thick and would be difficult to walk through. Now this here, where he says that the boulders are up to a couple of feet in diameter, that's a vast understatement. And I'll explain that in just a little bit. But first I want to point out that this is Tycho here, all right? Now this is a composite image. It's not one photograph. We would never see the moon exactly like this, and I don't want to take time to explain why, but the point here is that Tycho is only one of many craters, innumerable craters, large craters, and all of these craters would have left ejecta blankets and crater rays and a whole lot of material all over, you know, around where they hit. The only reason that Tycho, the crater rays and ejecta blanket are so conspicuous is that Tycho is younger than these others. Okay, so as you see here, Tycho's crater rays and ejecta blanket are conspicuous. Most others are not so conspicuous. Tycho crater is one of the youngest large craters on the Moon, and it is for this reason alone that its ejecta blanket and crater rays are still prominent. Over time, these features fade in color and brightness due to both solar radiation and micrometeorite bombardment. All of the countless large meteorite impacts on the Moon have spewed prodigious amounts of material in the form of boulders and rocks over large areas of the Moon's surface, and this jumble of material remains there forever. Here are another three well-known craters on the Moon. This is the most famous of these three, Copernicus, this is Kepler, this is Aristarchus. Okay, and these are these craters right here. And you see that their ejecta blankets and crater rays cover a large portion of this west side of the Moon. All right, and this is all west side of the Maria. I'm sorry, western Maria region. Okay, and here they are again. So look at that large ejecta blanket of Copernicus, and this is a little closer. And notice this what do you call it, string of craters. Those are not independent craters. Those are craters created by the objects blasted out of Copernicus when the meteorite created Copernicus. So imagine huge chunks, and we're talking, you know, God knows how large these objects were, flying out of Copernicus, going up into space, and coming back down, and creating these craters here, the largest of which are 4 miles wide. This one right here and this one right here. Okay, and then the smaller ones are about 2 miles wide. That's what these are right here, these craters here. Those are not mostly, for the most part, are not independent craters. They're secondary craters from the blast that created Copernicus. That just shows you how much material and the size of the objects that we're talking about that are blasted out of craters, out of large craters. For comparison, this is Meteor Crater in Arizona, also called Barringer Crater, and it's the largest well-preserved crater on Earth, but it's only 3/4 of a mile wide. Okay, going back to Copernicus, this is a closer view with higher resolution, and these craters here, okay, which would be a little closer to Copernicus here, but they're not well resolved, if at all. Okay, those craters are on average about 1.5 miles wide. These innumerable craters, all right, you can even count them. 1.5 miles wide. That's still twice as wide as Meteor Crater, as Meteor Crater. So that just shows you how much material is blasted out of a crater like Copernicus, which is not an extraordinarily large crater by Moon standards. This is a small crater. This is Censorinus. It's only about 4 kilometers wide. And look at the boulders on the edge of this crater. Okay, you would think that it was smooth. There was nothing around it in this large-scale photograph. But if you look at it more closely, these larger boulders are about 150 meters wide. That's twice as wide as a tractor-trailer, or about the size of a very large apartment building, taking up a good amount of a city block. So those are huge objects from just a relatively small impact, making a relatively small crater. And of course there are a whole lot more boulders, you know, house-sized and car-sized. Okay. Now let's get back to the Maria. They look fairly smooth, all right, but you can see that there are already here. You can see that there are craters in the Maria. So the Maria are not crater-free by any means. Okay, you can see quite a number of craters already, but some areas look smooth. Like take this here. This is Sinus Iridum. All right, it looks smooth, right? When we look more carefully with a higher resolution photograph, or in a higher resolution photograph, we see a number of craters. All right, this one right here is Laplace A, and it's 8 kilometers wide. So these two here are about 4 kilometers wide. But the closer you look, the more craters you see. Now we're going to look more closely even at this area right here, from there to here. Okay, this is a close-up from a more recent lunar orbiter, and what you see is really quite astounding. Innumerable craters. Not only the well-made out ones, the well-resolved ones, but the ones at the near the limit of resolution. You can see that there are literally countless craters, small craters. In this view here, these two parts of this photograph, the well-made-out craters, the smallest of the well-made-out craters, maybe this one here or this one here, these are about 400 meters wide. Okay, but again, look at how many small, barely resolved craters there are, just at the limit of resolution, or just below, as a matter of fact. Okay, they're innumerable. Yep. And here, this is an enlargement of this region right here. You can see very clearly all these craters coming into view, some of them barely. So the moon, including the Maria, are in fact covered by craters. This is shown here in this region as well. This crater right here is 6 kilometers wide, but we're going to focus on this square right here, this piece right here. Now this looks fairly smooth with just a couple of craters there. This is what it looks like in a closer view. These 3 craters right here are about 300 yards wide. Okay, and this crater right here is 100 yards wide. But there are, countless other craters in a jumble. Okay, all kinds of craters, small and large. And this is there's no reason to think that this part of this Maria is atypical. All right, this undoubtedly is what all the Maria on the moon are like, literally covered with craters. And if we could zoom in even closer and get an even closer resolution, even better resolution, we would see even more small craters. Now, the Apollo landings were in various terrain, okay, in varied terrain. There were 6 of them, and the Apollo 11 and 12 were in Maria, 14 and 16 were in highlands, and 15 and 17 were in at the edges of Maria, but surrounded by mountains, in mountain ranges. Okay, and yet, despite this variety, and despite what I showed you about the moon having to be covered in craters and boulders, these are the typical photographs that we see from the Apollo missions. This is Apollo 11. Where are the craters and boulders? Apollo 12. Apollo 14. This is in the highlands, where you would definitely expect to see craters and boulders. Apollo 15. Apollo 16, mega highlands. We're going to look at this a little later. Apollo 17, fake mountains, okay, phony, washed out mountains, but right now we're focusing on the surface. In none of these photographs, and I could show you literally hundreds, if not thousands of photographs just like these, this is the general view that we get from Apollo of a featureless landscape, a lunar landscape without any significant craters or boulders at all. Literally just handfuls of decent-sized craters and boulders. It is totally unreal. Okay, now we're going to look at the individual missions, 4 of them. We're going to skip Apollo 11 and 12 because they were very boring. They landed in places where there was little geological, what do you call it, features, so allegedly, okay. Now, any trip, any landing anywhere on the moon would have been, in reality, totally fascinating. But in these fictitious Apollo landings, 11 and 12, there was nothing to see, pretty much. Anyway, enough of that. So we're going to move on to 14, and then we're going to go to the next 3, 15, 16, and 17. Apollo 14 allegedly landed right there. And it's right here, the landing site above Fra Mauro. This crater here is called Fra Mauro, and the landing site is right there. Fra Mauro here, the landing site right there. Okay. And here's a NASA image with the arrow on it, but the arrow is a little misplaced. It should be a little to the left. And here's Fra Mauro again, and this is the Fra Mauro Formation, I believe it's called. Yeah, Fra Mauro Formation. And you can already see how rough it is. And here it is again, and there is the landing site. Again, the arrow is a little off. It should be a little below that. Right there is the landing site. And they landed among mountains or hills and this ridge, okay, this very prominent ridge. And they did so intentionally. After Apollos 11 and 12, which were flat and allegedly boring, they went looking for a hilly region with ridges a few hundred feet high, all right? And that's exactly what they landed in. In this amateur photograph, and if I haven't said it already, we depend mostly on amateur photographs, even if they're not the highest quality, because we know that they're honest at least. In this photograph, here's the ridge that they landed next to. They landed about right here, okay, in the center of that arc of that ridge. And so here the ridge is in light, is in the sunlight. Here, there's the ridge, it's in shadow, okay, and they landed roughly around here, all right? About 1,000 meters from that ridge, by the way, or a little over 1,000 meters from that ridge. And in this mission, what they most specifically were going to explore, intending to explore, was Cone Crater, okay? This crater right here. Now, there are several reasons why I can say that this crater, this alleged crater, Cone Crater, it doesn't actually exist. It's doctored in, it's pasted in. And one reason is that they're going to claim that they couldn't find, they're going to go look for that crater, and they're going to claim that they couldn't find it, which is preposterous. And I'll explain that as we go along. A second reason is that in the subsequent missions, 15, 16, and 17, they definitely doctored the landing sites. And we're going to see a whole lot of evidence of that when we get to those missions. Okay, now the third reason that we can say that this is doctored is because of the evidence from this photograph. As you see here already, but especially here in the close-up, these labels, all right, go to specific craters. These labels and these lines, arrows sort of, point to specific craters. This one is Old Nameless. This label and line point to this crater here, this somewhat flat crater above what they're claiming is Cone Crater, okay? And this landing site is precise. So that this label and arrow are precise. This is precise. Why is this so far off? Now, look at the difference in contrast between this crater and these two, and as a matter of fact, all the other craters on this in this image, but especially these two, which are about the same size. Look at the very large difference in contrast. The white is whiter, the dark is darker, all right? this thing here does not belong in this photograph. And now look at this. Look at this line, that sharp line, and this sharp line, especially on the top one, okay, which is seen nowhere else in this photograph. You can already see it there. All right, that is alien to this image. Look at this crater compared to these two. All right, and also notice how this square checkerboard or whatever checker pattern pervades the photograph and is inside all these craters. It is not in Cone Crater. This alleged crater is foreign to this photograph. It's pasted in. They use some 1970s or so version of Photoshop. Also, more evidence that that cone crater doesn't exist. It's not in this photograph. The only other old photograph, authentic-looking photograph that I could find. The most authentic photographs of Apollo are the earliest ones, taken by, in fact, they're not even Apollo photographs. These are pre-Apollo photographs taken by lunar orbiters. Anyway, so here you have Old Nameless and the landing site shown and labeled, okay, but there's no cone crater as there is here. Why would that be? Cone crater should be right there, right about there. This is about the same scale, okay? It's not there. So for all these reasons, we can say almost definitively that that cone crater doesn't exist. All right, so let's look at the nonsense that they purvey on this EVA, this extravehicular activity. In other words, this hike that they're going to take from the lunar module to the rim of Cone Crater. All right? And in this depiction here, this illustration here, what's most interesting is that they show the incline of the climb. All right, and by the way, this is the EVA laid over the Washington Mall. Okay, there's the Washington Monument, the Lincoln Memorial, and the White House is, and this is Cone Crater here, and the White House is above Cone Crater there. But anyway, so that gives you the scale. But what's more interesting is they show the actual incline to scale. All right, how gradual it is. All right, see that gradual incline to the rim of Cone Crater. All right, there it is again in two parts. They're only going to go up 90 meters. But look what they say here. During the early stages of the climb, they made good time. Before long, the grade was getting quite steep, about a 10% slope, and they were both breathing hard enough to hear back in Houston. The march only lasted for a minute or so before Shepard had to call for a halt. His heart rate was getting up to 140 beats a minute, and he needed a rest. What on earth could they be talking about? They are going only up to 90 meters over a distance of 1,400 meters, almost a mile. They're going to take almost a mile to go up only 90 meters in 1/6 Earth gravity. They should be hopping along without any trouble whatsoever. And yet they're talking about getting tired. So much so, all right, that the two astronauts were not able to find the rim amid the rolling terrain of the crater slopes. They were intending to reach the rim. That's what they went there for, okay, to find Cone Crater. They became physically exhausted from the attempt, and with their suits' oxygen supplies starting to run low, the effort was called off. What nonsense! And I'll show you in more detail how nonsensical all of this is. Balderdash. This is a 100-meter tall building, and I found this on the internet because I looked up 100-meter building, and it showed me the tallest building in Central America. That's what this is, in El Salvador. All right, so they went up to 90 meters in that climb. This is the Sears Tower, 450 meters tall, 5 times the height of their climb, these astronauts' alleged climb. People race up to the top of Sears Tower, up the stairs every year. It's a regular thing, all right, in 100% Earth gravity. This is a, these are 10,000 foot peaks, which is about 3,000 meters in New Mexico. I have climbed mountains just like this in New Mexico, and I'm not an expert climber, but I had little trouble. In fact, I had no trouble. It was a little bit tiring, but it was no problem. And that's 3,000 meters, not 90 meters. And yet the astronauts did this slight climb, all right, this baby climb in 1/6 Earth gravity, and they're supposed to have gotten tired. It's absolutely nonsensical. All right, this is a ridge on Earth. All right, and it's in an arc, similar to the one on the moon near Apollo 14. So let's say you landed, you parachuted, let's say, down to here, or drove, whatever. If you end up about here, you're going to see that ridge. And if you take photographs in that direction, you're going to photograph that ridge. No question about it, right? Just like this person here photographed this woman and the ridge, this ridge here. And here's another ridge. You're not going to miss a prominent ridge in photographs. These are hills on Earth. We have to ground ourselves on Earth reality before we look at the silliness of Apollo. All right, these are hills on Earth, and if you find yourself in these hills, you're going to see them, and you're going to be able to photograph them. No question whatsoever, right? Now let's look at meteor crater again, okay? Because they're looking for a crater, cone crater, on the moon. So here are the relative sizes of meteor crater and cone crater. Cone crater is a little less than a third of the diameter of meteor crater, but it's twice the height. Okay, so it still would be a prominent crater. It's not as large as meteor crater, but it would still be a prominent crater. This is meteor crater from 3 miles away. Cone crater would be about this size. Okay, that's about a third, about this width, but it would be twice as high. Okay, so it would be something like this, and it would be quite prominent. You cannot miss a meteor crater. If you were told to walk to meteor crater and look into the rim, you would not miss it from here. Okay, and similarly, you would not miss cone crater either. This is from closer up. This looks like it could be a group of people. This is the center, the visitor center near the rim. But anyway, so if you were told to walk to meteor crater from here, there is no way in the world that you would miss it. You would have to be falling down drunk or impaired to not be able to find meteor crater from here. Okay, and here are tourists hiking up to the rim, and this includes this older woman here and this young girl. So it's no problem at all to hike up to the rim of meteor crater. And here's a group of people going around the rim, which I have done, by the way. I've visited meteor crater and hiked around the rim. Now imagine that you were right here, okay, which is about 20 meters away from the rim. So let's say you were somewhere around here. That's how close the Apollo 14 astronauts were supposed to have gotten to the rim of Cone Crater. And yet they could not find it. They couldn't walk that extra 20 meters and find the rim of Cone Crater and look inside Cone Crater. It is completely ridiculous. And walking around meteor crater, you look in and you see it. There's nothing mysterious about it. There's no difficulty whatsoever. You walk around meteor crater and you see the inside of meteor crater. Now, let's look at the photographs that the astronauts took of their surroundings at the landing site and as they climbed to Cone Crater. But first, let's reorient ourselves. This is the landing site, and this is the ridge that we're talking about, and Cone Crater would be somewhere in there. How convenient that they covered it up with this arrow. That would have been one of the best photographs of the general area. And here's this photograph again to remind us that the landing site is about there. They're going to do this hike to the cone crater, which would be somewhere near this ridge, okay? And there are hills all around, all right? And here's the first photograph we see of the landscape around the landing site. This is half the horizon, and they're taking this photograph from 20 feet up in the lunar lunar module. It's flat. It's completely flat. How could that possibly be? It could not. It would not be flat if they were really on the moon, where they said they were. You would see that ridge or hills or both. This is half the horizon. This is a composite, panorama, half panorama. This is a full panorama, and we're going to look at this thing in thirds, from left to right. You can see already it's flat. There is no ridge. There are no hills. What is going on? What's going on is that they are not on the moon. They are not in the terrain that they claim that they are. All right, so here's this EVA again, and these are stations that they supposedly stopped at and did things at, like take photographs, examine the terrain and the rocks or whatever. You know, they did various things at these stations. So we're going to look first at station B2, which is halfway up. All right, that would be around here. And here they are, halfway up, on the climb, and they're already close to 30 meters up. They would have a very good view of the surrounding terrain, right? They would see that ridge and they would see the hills. This is the panorama, full 360-degree panorama they took from station B2. There is no ridge and there are no hills, unless you count that slight mound as a hill. All you see is this gradual rise to the alleged rim of Cone Crater, which is not very realistic, but let's grant them that. So there's Cone Crater, but there are no hills or ridge, and there's no ridge in this 360-degree panorama. What we're dealing with here is clearly fiction. We've been in fiction territory since the beginning of this alleged Apollo mission. Here is the same image with NASA showing us with labels where the astronaut is and where he's going. How on earth are they going to miss the rim of that crater? You would not miss the crater. You would not fail to find Cone Crater. All right, now let's move on to the top of the climb, very near the rim of the crater. All right, right here. All right, that's station C. And this is the panorama, 360-degree panorama that they took from that location. And immediately we see some severe problems with this panorama. First of all, there's a Kubrick horizontal all the way across. How could that be? It couldn't, because they're not on a plateau. They're on the side of essentially a mountain, a mountain with a hole at the top, right? That's what a crater is. They're right here, all right? So in looking away from Cone Crater, they would see a gradual slope. They would not see any sharp line with a drop-off, with a bifurcation of foreground and background. They would not see a Kubrick horizontal. They would see a gradual slope. Like this. This is the slope that you see from the top of Meteor Crater. All right, no problem. No issue here. You see a slope all the way down to the bottom. Same thing here. And if not for this parking lot, you would see it just as clearly. Secondly, you see the mountains in the background. There were hills all around Cone Crater, all around that landing site of Apollo 14. You would see those at the height that they were at 90 meters height, okay? But you don't. So they claimed that they were, oh yeah, let's look at that one more time, this panorama. Yeah, here you are. So you have that Kubrick horizontal, but no hills and no ridge anywhere to be seen. Okay. And they claimed that they were not able to find the rim amid the rolling terrain of the crater slopes, and elsewhere they blame the boulders. Okay, they claimed that there were too many boulders and large ones. This is what they're calling a boulder. First of all, this is not a sizable boulder. All right. Secondly, even if you had larger boulders than this, that's not going to impede you. That's not going to prevent you from finding the rim of the crater. All right, they would have to be a whole lot larger and a lot more numerous than that. But this is what they're calling a boulder field. This photograph is labeled among the Apollo photographs as a boulder field. Here's a footprint to give you the size, the scale. All right, these are little rocks. They're not boulders at all, much less boulders in the size and quantity, in a size and quantity that would prevent you from finding the rim of the crater. Because and that this image right here is from right here, okay, which is part of that panorama, this same panorama. All right, so they're nearly at the top, they're nearly at the rim. They just have to go a little bit further, and they're claiming that the rolling terrain and these boulders impeded them. There is no rolling terrain, and there are no boulders. It's relatively flat. They had no excuse whatsoever to not find the rim and to look into Cone Crater. And then looking back from Station C, there's the LEM in the distance. In that direction, you would see hills. This is all they see. Very slight mounds, no hills to speak of. Here they are, and they're looking back in that direction, okay, which is, here they are, and they're looking in this direction. Where are those hills? This is not a great distance. They would see hills just like we see mountains here from the top of Meteor Crater. This is what we get from Apollo 14. A flat terrain, no cone crater, no ridge, no hills, no landscape of craters and boulders to speak of. Pure nonsense. They don't show us anything because they are not on the moon. They are in a studio on a moon set. This is the alleged landing site of Apollo 15. It's at the northern end of the Apennine Mountains, the lunar version, of course. There are Apennine Mountains in Italy, which I didn't even know before I studied this. Okay, so this is the range, and this is the lunar equivalent of our Himalayas. These are the tallest mountains on the moon, and but they're not nearly as long. The range is not nearly as long as the Himalayas on Earth. And this is a very nice photograph of them, and you can see here that they're very rugged, okay, craggy. There's nothing soft or smooth about these mountains. And the landing site is right here between these two mountains, Mons Hadley and Mons Hadley Delta. The range contains six of the 8 tallest mountains on the moon. This is Mons Hadley, and here's Mons Hadley Delta right here, the 2nd and 5th tallest. Those two right there. And the landing site, once again, is right here, very close to Mons Hadley Delta, and here is Mons Hadley, which is a double peak, by the way. And these mountains are actually the equivalent in height of Mount Everest. Okay, so they're very tall. And by height, I'm talking about prominence, which is different from height from sea level, which is an artificial, arbitrary measure, because it adds whatever height of the plateau that the mountain sits on. So what do you call it? Prominence is a measure from the plateau, the level that the mountain is sitting on. Okay, in this particular illustration, it shows that Mount McKinley, Denali, is actually a taller mountain than Mount Everest. But of course, Mount Everest is still very tall. And Mons Hadley is a little taller, and Mons Hadley Delta is just a little less tall. All right, so here's the exact landing site. Here's Mons Hadley Delta, and here's Mons Hadley. And this is an EVA map, extravehicular activities. In other words, excursions. The last one we saw was from Apollo 14, and it was on foot. These and subsequent ones are all going to be driving, in the lunar module. Excuse me, in the lunar rover. Anyway, okay, so here they are driving around this region right here. Okay, now I'm going to show you some mountains, and then we're going to look at the photographs of the mountains on the moon. This is Mount Everest, and it's towering over this valley, as you can see. Very impressive. This is Mount Rainier, soaring over Seattle in Washington State. This is Mount Fuji, towering over this city. I don't know what city this is. It's not Tokyo, because Mount Fuji is farther away from Tokyo than this. And this is Mount Shasta. Again, what better word? Towering, over this valley here. Okay. In each of these cases, these mountains are extremely impressive. Okay. And they dominate. That's another word. Dominating the surrounding landscape. This is Mons Hadley. That is supposed to be a mountain taller than Mount Everest. It's not dominating the landscape. In fact, it's a featureless blob. It looks like a clay mold or a paper mache thing, or I don't know what they made this out of, but it's fake as hell, and it doesn't even look tall. This is Mons Hadley Delta, which is almost even more featureless, washed out, not dominating the landing site. This is the lunar module. We're clearly dealing, already we can see, with fake mountains, cartoon mountains. Okay, now let's look at a specific case or specific illustration. This is Mount Rainier. This photograph was taken from the Space Needle in Seattle. So we know the exact distance between where the photographer is and what do you call it? Mount Rainier. Okay, and that distance is 60 miles. This distance we also know because this is at the landing site, and this is the shadow of the lunar module. Okay, and this distance to this peak, Mons Hadley, is 17 miles. Now look at the difference between these two scenes. This mountain is taller, this mountain is not as tall as Mons Hadley, yet it looks way taller, and it's also almost four times the distance between, it's almost four times this distance. Okay. Again, Mons Hadley is a little taller than Mount Rainier. Seattle to Mount Rainier is 60 miles. The Apollo 15 site to Mons Hadley Peak is 17 miles. Dominating the scene, not dominating the scene at about 1/4 the distance. It's just fake, is all you can say. Okay, another way to look at this, another way to determine the fakery, to establish the fakery, is to look at these photographs of the Himalayas from space. These are from orbit. This is Mount Everest. Okay. Now, when we get down to ground level, these mountains, of course, are going to be much more impressive, right? We're going to see them a lot more closely and with more detail, and they're going to be a lot more imposing. And this is Mount Everest again, right here. Okay. You can already see, that they're kind of craggy, all right? And they're going to look even more craggy when we see them closer, right? And in fact, that's exactly what we see. Look how sharp these features are. This is Mount Everest. Another view from another angle, from another direction. And these are more of the Himalaya mountains. Very, very impressive, as we would expect. Okay, so these are lunar orbiter photographs of Mons Hadley and Mons Hadley Delta, and of special interest is going to be these mountains in between the two, this arc of mountains. Okay, and Mons Hadley is actually a double peak, as I've mentioned, and as is shown in this overlay here. Okay, it's a double peak. And in general, these mountains are quite complex and rugged. You can already see that literally from space. These are what do you call amateur photographs, and you can see how rough they are. Okay, again and again. The landing site is right about here. And this here is the panorama, or a panorama. They took a lot of panoramas, that is collections of photographs. Okay, all these are individual photographs, mosaics of photographs. Anyway, this is a panorama of the entire scene from near the landing site, because there's the LEM right there. Okay, this is Mons Hadley Delta, this is Mons Hadley, and these are those mountains in between that we're going to look at a little bit closely. And you can already see that these things bear no resemblance to the actual photographs of them. They're rounded, they're smooth, they're featureless, they're bland, they're washed out. Okay? These are those mountains in between that I mentioned. They're just blah, and they don't look tall at all. Okay, this is, we're going to go through the individual photographs of the panorama. There's Mons Hadley. There we go around to the mountains in between Mons Hadley and Mons Hadley Delta. What the heck are those things? Okay, this is what we're supposed to be seeing. This rugged stuff, okay, with craters and everything. That is supposed to be this. There is absolutely no resemblance. These look like mounds of, I don't know what, soft, rounded mounds with a blanket thrown over them. That's how soft they look. This is what we're dealing with. We're dealing with cartoon mountains, literally. Okay, except that these are even sharper than the Apollo ones. We'd have to go to these, because these are nice and rounded, like this silliness here. This is what we're dealing with: fake cartoon mountains. I don't know how what exactly materials they used. I don't know if they just painted them. I don't know if they made them out of clay. I don't know how they made this fake stuff, but it's certainly fake. This here is a real car, obviously. It's a Honda Accord. It has the logo and everything, and it has a lot of sharp features and very specific features. It has detail and distinctive details. Okay, this is just a representation of a car. It's just a cartoon car. Okay, that's why it's so soft and rounded and has very few distinctive features. So real objects are distinctive. They're specific. They're feature laden. They're sharp and well defined, and they're oftentimes impressive. Fictitious objects are indefinite, generic, bland, relatively featureless. As few features as possible here. They're rounded and fuzzy, and they're unimpressive and unremarkable. That's what we're dealing with with the mountains that were being shown here in Apollo 15. Also, look at the ground itself. It's totally featureless, literally. Okay, where are the craters and boulders that should be ubiquitous on the moon? Look at this. This is literally flat. So flat that it looks like ice. It looks like an ice skating rink. It looks like the hardened snow on a flat surface on Earth. You know, the crusty snow after it's melted and then hardened. Same thing here, flat, featureless. Moving on to another feature that should have been extremely impressive. That's this rill here, which is like a canyon. This is Hadley Rill, okay? And this is the whole thing. It started around here, apparently, okay, because it seems to have flown in this direction. Flown? What's the term? Flowed. Yeah, flowed. It flowed in this direction. Because you can see it's wider here, and then it peters out over here. And what it was a flow of lava, which melted the surface of the moon, you know, this valley floor. All right. So it's a canyon of sorts. It's the lunar equivalent of canyons, like these, which of course are made by water or rivers on Earth. So when they show us photographs of Hadley Rill close up, this is more or less the kind of thing we should be seeing. A vast thing, okay, with wide open spaces and long distances across and down and everywhere. If you've ever been to the Canyonlands in the American Southwest, you know what I'm talking about. It's extremely impressive, unforgettable, formidable, actually. Okay. Here's another photograph of this sort of thing. All right, and a good comparison is actually Meteor Crater. Even though Meteor Crater is a round crater, it's not a long canyon, but there are good specifications that we can compare. For instance, Hadley Rill is about 1.4 kilometers wide, almost a mile wide. Meteor Crater is a little bit less wide. Hadley Rill, however, is 370 meters deep, twice as deep, more than twice as deep as Meteor Crater. Okay, so we get good comparisons with Meteor Crater. There's Meteor Crater. Imagine now a canyon wider than this. This thing is so wide you can't even fit it in one photograph, and twice as deep, but continuing on, going on, you know, for miles. All right, that's what Hadley Rill is like in reality. Now, let's keep in mind something very important, which is that from the perspective of the astronauts who landed right here and only drove around and explored this small area right here, from their perspective, Hadley Rill is straight. Okay, it's literally straight for a couple miles and almost straight for 4.5 miles. All right, this is a good alleged photograph. I'm going to show you how, you know, all these photographs of the landing site are fake, but for now, let's just go with it. So this is the 2 miles of completely straight canyon, or rill, I should say, and up to here is 4.5 miles of almost straight rill with just one slight bend. All right, there it is in writing. And so here are their EVAs. They were confined to a straight portion of the rill. Simple as that. That's going to be important as we go along here. All right, so here's another amateur photograph of the landing site, which is right about here. And here's another one, another photograph with the sun at a different angle. And you can see from these photographs how straight that section of Hadley Rill is. All right, so here are their EVAs. They had 3 of them altogether, 1, 2, 3. And we're going to start with this one here, and we're going to look at their views from Station 2. Okay, they had stations along the way. within the EVAs. And here it is right here, Station 2. And I used two sets of EVAs because this one shows the actual EVAs very well, but the landing site is, the terrain is funky, even faker than usual. Whereas this map has a more reasonable terrain, more realistic terrain, but you can't see the EVAs too closely. So that's why I use two sets. But anyway, so this is Station 2 right here, and they should be looking right into this canyon and get a wonderful view of a long canyon going, for 4.5 miles. It would be huge, wide and long. This is what they show us. This is a panorama, a mosaic of a number of photographs, but essentially this is the only photograph they show us of the entire canyon all the way to the bottom, okay? Which in itself is very peculiar, because they're going to have a lot more opportunities to show us the canyon, but they won't. They will fail to do so. So this is the one photograph, and we can see that it's fake, okay? No way on earth is this a mile wide, okay, and 4.5 miles long. You can see the rocks at the bottom, miles, what would be miles away. Okay, this would be literally miles away. Even as far as 4.5 miles, you can see individual rocks. Okay, this is some couple miles away, and this is this canyon, or rather this rill, is almost 1/4 mile deep. How on earth would you be seeing individual rocks? And, this lunar rover shows us the scale. There's just no way that this is correct. And also, it's too windy. It's so windy, as a matter of fact, that I was confused and this isn't the first time, I was confused with a lot of these features in Apollo 15. I had to study them over a period of time to get my bearings, because all the proportions, all the sizes, all the relations, spatial relations are wrong, simply wrong. So you have to translate fiction into some realistic thing. Otherwise, you wouldn't make heads or tails out of anything. But anyway, this is too windy. All right. Certainly, we're not seeing something realistic like this. Vast spaces. Nothing of the sort. We're not seeing anything remotely like these huge spaces of real canyons and real craters in this case. Okay, remember, this rill is twice as deep as this and even wider. This is not of that same size, roughly. It's not even remotely that kind of size. And they play on this notion of a winding, sinuous rill. It's a stereotype, all right? The rill is windy, but over its 40-mile length. This is about 40 miles here. Yeah, sure, it's windy over 40 miles, but again, not where the astronauts were, not in that small space. Okay, in this small area, as I said several times, because it's critical for our understanding of how fake everything is here. In this perspective, no, the rill is not windy. So this is just fake. Okay, let's move on to the view from Station 9A. Now this is right on the edge of this humongous rill, right here. What kind of views, are they going to show us here? We're expecting some stupendous views. They're right on the edge. They're going to show us this huge rill in all its glory, all the way to the bottom. They're going to photograph it up. They're going to photograph it down. They're going to photograph it across, right? This is just going to be stupendous. This is what they show us. What the heck is this? First of all, and this is all they show us. This is the one panorama that they show us. Why could the astronaut not have gone to the edge and shown us the whole thing from the bottom up? they act as if there's a force field. And this isn't the only time we're going to see this. We're going to see this also with craters in subsequent missions. They act like there's a force field preventing them from showing these things in all their glory. And why is that? Because they can't show us what they're not seeing, what they don't have in front of them. They do not have a huge rill in front of them. This is a little ditch. Okay, so here are the individual photographs of that panorama. You can see the individual rocks on the other side, a mile across, a mile away. All right, and you never see the thing to the bottom from this angle. Okay, it's imaginable that photographing straight across the rill, you would not see the bottom. Okay, but at this angle, you would start to see the bottom. Why wouldn't you? Okay, just think of it from this angle. But anyway, clearly these rocks are too well seen. They're just a little smaller than the rocks on this side. What we're looking at is a little ditch, literally a few tens of meters across. That's what they're showing us. That's what they're trying to pass off as a gigantic rill, like the size of the Grand Canyon. Again, nothing like this, which it should be. We already saw, we saw the actual figures of the dimensions. It should be something like this, but it's not. All right, moving on to Station 6A, right here. Now, my goodness, this is from a couple hundred meters up on the slope of Mount Hadley Delta, all right? Magically, they were able to drive up on the side of the mountain, which you can't do even on Earth, you know, without roads. But anyway, they did it, allegedly. And now they're going to be looking down right into the heart of this rill, right down the throat, right down the barrel of the gun, so to speak. Okay, it's going to be a bird's eye view, right? This is what they show us. Another panorama. And this is ludicrous. What the hell is this? They don't show us what would be seen if they were right here and shooting right across in there. What is this? All right, they show us the rill going across, going perpendicular to the line of sight. How could that be? There's nothing perpendicular to the line of sight from here through to here. It's straight down the length of the rill. What could this be? Crossing the line of sight. Another thing that's completely wrong in this photograph, in this mosaic, is this hill here, or this mountain, which is Hill 305. That's what the astronauts called it, Hill 305, or NASA, whatever. Okay, that's Hill 305. This is the rill. Okay, nothing is right here. So here they are at Station 6A, about right here, and they should be looking straight down into the rill, and then on the other side, in the distance, would be this Hill 305, with the high part of it, the tallest part of it, right across the rill, in the same line of sight as the rill, and it would be on the northern end. This tall part, the highest part of this hill, quote unquote, Hill 305, would be at the northern end. Okay, but that's not what is shown. What is shown is the highest part at the southern end. And here's this panorama, which shows the whole valley. Okay, this is Hill 305. This is Mons Hadley, and this is Mons Hadley Delta over here. So you can see here that from that panorama, and here they are at Station 6A. Okay, that you have that little what do you call it? Gap right there. All right, more or less in between Hill 305 and Mons Hadley. All right, and then you have this slight rise here, right there. Okay, so this gives us the perspective, the relations between all these features. So Hill 305 should have that high part right here at the northern end, not the southern end. And that's confirmed by all these other photographs of Hill 305. That's the high end, the northern end, the taller end right there, clearly. All right. This is sloping down. There it is, okay, the tall end. So looking across, you would look right into the rill, and on the other side, and it would be lengthwise, right down the length of it, 4.5 miles, and on the other side would be the tall part, this tall side end, however you want to put it, of Hill 305. Okay, that's not what we see here. We see nothing of the sort here. This is all messed up. It's just simply wrong. Somebody drew it wrong. It's a rendering, a drawing, a painting, whatever, illustration, which is done wrong. This professor of physics, this physicist, studied the photographs of Hadley Rill from Apollo 15 with this method of stereoscopic parallax, which is essentially simple. It's the difference between the view in the foreground and background when you shift your position when you're photographing things, like so, okay? You shift over a few feet to 5-10 feet or whatever, and the foreground shifts, but the background doesn't, because of perspective, because of the distance, whatever, however you want, you know. And so he used this method, this fact, to learn what the actual distances were that we're seeing in Apollo, in the photographs of Apollo 15, specifically with regard to Hadley Rill. And he did this in detail and with his specialized knowledge, which I didn't follow in all its detail. At a minimum, I would have to study it a lot closer, and I'm not a trained physicist. But anyway, he determined that the distance across the rill is only 40 meters. And the distance to that major bend that is supposed to be 4.5 miles, in the photograph it's actually only 140 meters, a little beyond this 90-meter label. As he says, the distance to the Rima-Hadley bow does not exceed 140 meters. And he concluded that what we're looking at in the photographs of Apollo 15 is nothing more or less than an artificial trench 30 to 60 meters wide. That's what this is. Now you can see that that's exactly what this is. It's a trench dug in the desert somewhere. Maybe they found something that was already, you know, partly filled the bill. I don't know. And it's just a few tens of meters wide and tens of meters long. This is no way a huge rill canyon-like thing. All right. Let's continue with this panorama, which is very useful. We're done with Hadley Rill, another fake thing from Apollo. Apollo 15 alone contains enough fakery to completely uncover, dismantle the Apollo missions. It's replete with fakery. But anyway, let's continue. Now, the second fake thing in this panorama is this thing right here. Okay. Here's a close-up. This thing right here. What is that? Okay. You would think, of just looking at this without any other knowledge, you would say, well, that's a distant peak, right? That's another mountain in the distance. Well, in fact, that has to be the double peak, the second peak of Mons Hadley. All right, that's what it would have to be. From this perspective, from Station 6A, that's what we would be seeing. Mons Hadley's second peak, except that it's completely wrong here in this in these photographs, in this panorama. It's wrong for at least a couple reasons. One, the actual double peak, all right, is they're close together. That's why it's called a double peak. And you can see it in the actual photographs. They're close together, they're next to each other. The second one is only a little more distant from the landing site than the first one. But here, you can see it looks like a completely different mountain, very far off. Secondly, you have this mountain. This would have to be another mountain slightly in front of Mons Hadley in the view, in the line of sight to the second peak. All right? That is not there in reality. Here is this wide view. This is a lunar orbiter photograph. Here they are, Station 6A, about right here, and you would see the double peak, the second peak, I should say, very easily, right through this gap, this, what do you call it, kind of like valley in between the two peaks. Okay, as I mentioned before, Mons Hadley is in fact a double peak, as this overlay shows. And here's Station 6A, again, right there to orient us. Here you are, right here. And again, you would look right across, right through this gap, and see the second peak, and it wouldn't be very far from the first peak. You would see it rise from the valley floor, a slight rise there, more major rise there, and then the peak itself. That's what you would see. Here's Station 6A again, same thing, right across like so. It wouldn't be that silly little thing peeking out way in the distance as the Apollo photograph, like this. Okay, it wouldn't be like this with that little thing peeking out, again, as I said, way in the distance, with this mountain in the way. That does not exist. And you can see it here. You can see it in NASA's own, what is this called, a contour map, all right, that this little plateau is just that, a little plateau about 1,000 meters high, not a couple thousand meters high, as this is showing, because this is about half the height of Mons Hadley. So it would have to be close to a couple meters, 2,000 meters high. That is not there in reality. I think this photograph here shows it best. That's just a slight rise, just a slight plateau. It is not this mountain here. All right, so that's fake. Now let's continue with this panorama. This panorama, by the way, is 3/4 of the entire 360-degree panorama. It continues from here, and we're going to see this momentarily. Here are the individual photographs of that panorama, which are more clear than the panorama itself. Okay, so here we go. We already saw this, the fake Rill and the fake Hill 305. Okay, the fake Mons Hadley, the fake second peak, the fake intervening mountains between Mons Hadley and Mons Hadley Delta. And here we go to the base of Mons Hadley Delta. And what do we see? The lunar rover tracks climbing up the side of Mons Hadley Delta as if they were on the beach, sand dunes on the beach, or in the desert, a large sand dune. Willy-nilly climbing up the side of a mountain, which you can't do on Earth, except maybe on the beach. A real mountain, you don't climb up, without roads. Well, what do you think they need roads for? They need to build roads for. It's a cartoon. The whole thing is a cartoon. How the heck are they going to climb up the side of a mountain on the rugged moon? We've seen how rugged the moon is. Everything on the moon, valley floors, mountains. Okay, there's nothing smooth on the moon. But that's what they claim they did. The mission called for Scott and Irwin to climb the hillside a bit west of Spur and then turn to the east and make a 3-kilometer drive roughly along a contour line. Yeah, right. Driving kilometers along the side of a mountain without roads. The hillside had the appearance of a dry, sandy, well-used beach covered with soft hummocks and with poorly defined shallow craters. A sandy, well-used beach. That's what they were driving on. an Earth beach or sand dune somewhere in the desert or literally on the seaside. This is not the moon. It's ridiculous. Literally, it's cartoon. All right, moving on to more foolishness. This is the surface, the valley floor surface. We're going to look at the surface of the moon here at the Apollo landing site, Apollo 15 landing site. Okay. So you say, okay, well, what's to see here? What's unusual here? This is the actual lunar surface. This is a real photograph from the lunar orbiter spacecraft 4 years before Apollo 15, which was in 1971. All right, this photograph is from 1967, before Apollo, when they were planning all these missions. All right, that's why they have all these labels here. And this shows the real surface of the moon, which is completely covered with small craters, as I have mentioned many times before. That's what the moon is like. Now, notice this here. There's some kind of defect in this photograph, either that or an intentional airbrushing, because they didn't want to show us some details or whatever. But anyway, so that's this side of Mons Hadley Delta. Other than that, you can see things pretty clearly. Look at St. George crater. Look how craggy, absolutely craggy and rough it is. Compare that to this powder donut thing here. This laughable fake crater there. Okay. Look at the huge contrast there. Now, we're gonna look more closely at this region here. Notice this pair of craters, and then this larger crater and this North Complex label here. Okay, we're gonna look at that more closely in an enlargement. Okay, North Complex, the two pairs of craters, that large crater, and the equivalent in the original, not original. This is the original. This is the phony Apollo NASA version. Okay, so here's the real photograph. This is the phony one. All right, and this photograph, both photographs are centered on this crater right here. That crater right there. To give you the size scale of this image, this crater right here is 650 meters wide, and this one right here, this perfectly round one, is 150 meters wide. When you look back and forth between these two photographs, they're vastly different. And what you notice is that craters that are in this one, like say these craters right here, okay, they're gone. They're just plain gone in the phony photograph. And there are countless. You couldn't possibly count all the craters that are gone in this phony photograph. And even craters that aren't gone are softened, much less deep and sharply defined. Okay, so what they seem to have done is to literally airbrush this photograph, the original photograph. They took this original photograph, they made it light gray. They took out all the contrast. They airbrushed a whole lot of detail out, and they even probably defocused it. Okay, they just totally transformed it into something that you could drive through. All right, that must be why they did this, because you can imagine driving through this, just missing the larger craters. All right, you'd have a little bit of bumps, but you would be able to drive through that. You would not be able to drive through this. You wouldn't even think of it. All right, here's another version of that same lunar orbiter photograph, but instead of labels, we have a whole lot of grid lines. We have no pristine photograph from the lunar orbiter without anything added onto it. This photograph is actually a little bit better, more detailed than that high contrast photograph that I showed you earlier. And when you compare it to the fake view of the landing site you can see a vast difference as before. This is an enlargement, this area right here. And when you compare the good photograph, the real photograph, with the fake one, you can see, again, as before, a complete transformation. And this is all more for your information, for those of you who want to study this even more carefully. I already made the point a while ago, that the point being that this is phony, this is real. And you would not be thinking of driving through this. Look at the difference with St. George crater. I mean, there's just no resemblance. This is literally like a powder donut, sugar powder donut, whatever the term is for that thing. You know what I'm talking about. All right, let's move on to look even more closely at St. George crater. This crater is huge. It's 1.5 miles wide when you include the rim, which is very prominent. This crater right here is about the size of a meteor crater. And you can see how much larger this one is, okay? And the astronauts would have gotten a wonderful view from their landing site, all right? And you can see in this and the next few photographs that this crater has some peculiarities. It's first of all not completely circular. It has a wide rim, okay, which you can see here. It's pretty distinctive. Here you can see how wide, very wide rim. And it's also somewhat irregular, like you have this bump here. All right, so you have this very large crater with a very wide, prominent rim. It's not completely circular, and it has irregularities. But this is what they show us from Station 9A. This is supposed to be St. George crater. It doesn't even look like a crater. It looks like a shallow depression, very smooth, very regular, symmetrical, no wide rim. All right. And look at this. Look how featureless it is. It's ridiculous. Now, worst of all, from NASA's perspective, you can prove conclusively that those are two very different things because they're different sizes. So if you, that photograph, this photograph I just showed you, is taken from Station 9A, all right? If you take a protractor, this thing right here that we used in grade school or high school, and you lay the vertex, that thing right there, all right, at Station 9A, you would get, or you will get, as I did, the angular size of St. George crater, all right? And that ends up being 40 degrees. That's how wide this thing is in angular size, in degrees, okay? Now, if you take this panorama from Station 9A, see these little features there, these mini craters? This is a 360-degree panorama all the way across the horizon. So that's 360 degrees. And you take this little section of that panorama, the length of St. George crater, okay, if you take that as a fraction of the whole, what you get is, on my screen, 19 millimeters over 262 millimeters. That works out to this fraction, and you multiply that by 360, and you get 26.1 degrees. So this thing here in the photograph, all right, is roughly 26 degrees versus in reality what it is 40 degrees. It's only 2/3 the size of the real thing. These two things here, this crater in this real photograph and this thing in the Apollo photograph, are two completely different things. This is fake as hell. Moving on to Apollo 16, right there. This is in mega highlands to distinguish it from the moderate highlands of Apollo 14. Okay, there they are among the big boys, the big craters. The site is right there. And here it is again, closer up, right there. So here's a close-up of the landing site. Right there is the landing site. And make a note of this crater here, North Ray crater. We're going to get back to that. But first, I want to compare this photograph with this older pre-Apollo lunar orbiter photograph of the landing site. All right, so there's the one and there's the other. This is fake in many ways. It's doctored, okay? This is the original, and you can see many differences. Remember Apollo 14, we had that one crater, cone crater, okay, which was photoshopped in. Here we have this same doctoring, but on a much larger scale. And I made a note, I listed all the differences, the major differences that I noticed, and there are others. These are the more major ones. And you can pause here and you can study these images. I'm not going to go through all of this, but I'll point out a few. So here's that crater right there. It's simply not there in the phony photograph. Okay, that crater right there. Look at this crater here, which is deep and should be seen in here, but it's not. It's simply not there. Okay, this arrow, by the way, this arrow right here, it doesn't stay on, and I can't make it stay on. But we're going to make do with it anyway. Okay, right there. So that crater is not there in the fake photograph. Now, look at this crater here. It's actually added. Okay, it's not there in the original. This crater here is added. It's not there in the original. So there are several such differences which give away this fakery. This is simply a doctored image in many ways. And there's that North crater. That's not there. Whoops. Okay, there it is in the fake one. So there are many craters that are in this one, but are missing in the other one, and vice versa. So undoubtedly, I mean, there's no question about it, that second image, this one here, is doctored, badly doctored. All right, but fakery, as we've seen already long ago, is par for the course for Apollo. Okay, back to North Crater. Okay, they're going to do an EVA, extravehicular activity, in other words, an excursion, a hike, actually this time, of course, driving, up to North Ray Crater, that one, that right there. All right, and here it is again. And closer up, they're going to go right to the edge, as if you can drive up to the edge of a large crater and not, you know, and avoid the boulders driving. And here it is, a photograph allegedly from orbit, and you can see that, you know, it's this donut, sugar donut thing, totally phony. This is meteor crater on Earth, and it's a good comparison because it's roughly the same size, almost the same diameter. North Ray crater is just a little less wide in diameter, but it's 40% deeper, all right, than meteor crater. So it would be pretty much as impressive as meteor crater. But this is what they show us. This is supposed to be a crater roughly equivalent to meteor crater on Earth. This silly thing here with rocks visible, clearly visible on the other side. It is just ridiculous. but we're getting used to this, I think. In this photograph, you can see a little bit more clearly the rocks going around to the other side. All right, they're just a few meters away. This is a few meters away. This is a few more meters away. We're talking about tens of meters. This is the other side of the crater. This is a very small crater, a very small hole that they dug somewhere. It is not a huge. Oh, and here's a close-up. This is not a huge crater like meteor crater on Earth. It's that simple. Can you see rocks this size a mile? Well, this is 3/4 of a mile. 3/4 of a mile away? Of course not. All right. You don't see rocks the same of the size that you see right here near the edge, all the way to the other edge. It's ridiculous. These rocks right here, you can't resolve them after 100 meters or so. All right, you obviously cannot see them. Rocks, like these, on the other side of the crater. It's, I mean, how stupid can it get? All right, like you see here, this is fake. That's all there is to it. I'm getting repetitive here, but that's how it is. Okay, so there's the landing site right there, and it's among these very large craters. We're talking, I think this is 60 miles wide, or is it 60 kilometers? I think it's 60 miles. And this is about 80 miles wide. I'm going to double check that, but I'm pretty sure that's the dimensions, that's the sizes that we're talking about. So this area is mega highlands, and it is blasted by countless craters, large ones, and therefore it would have boulders and all kinds of debris all over, including around the Apollo landing site. This would not be a pristine area. It would not be smooth. There would also be all kinds of small craters, of course, which are ubiquitous on the moon. And this is the panorama that they show us, or one of two panoramas that I'm going to show you at the landing site, all the way across 360 degrees. It's completely bland, completely featureless. There are no craters or boulders. This is the second panorama, same thing. How bland can the moon be, according to Apollo? Totally unreal. Obviously, you can drive to your heart's content all over this kind of terrain, and that's what they claim they do. Drive and drive and drive, as if they were, on country roads on the Earth. Okay, even on the Earth, you need roads. And here, lo and behold, is a boulder. Wow, a boulder. This is literally one of a handful of boulders that they found in all the missions, and they had to drive far and wide to find them. Boulders like this would be all over the place, and also much larger ones on the real moon. But this is all they can show us, because they're not really on the moon. This is a large version of the sea rock. A very large version of the sea rock. It's a prop. I wouldn't be surprised if it's not even a real rock. This is what Apollo 16 shows us. Essentially nothing. And they're in mega highlands with among all those craters, and there should be boulders and debris and all kinds of geological features. They show us nothing. Okay, we're moving more quickly now. Apollo 15 was the big one with all kinds of nonsense, but we still have a few more points to get through. Okay, so there's Apollo 17 right there, and it's a physically, as far as the landing site goes, it's like a small version of Apollo 15, which by the way is over here. All right, so it's a smaller valley with less tall mountains. There's a close-up. The landing site is around there, and these are the mountains surrounding it. So it's another mountain valley. There it is. More close up. Now this arrow point is slightly off. This is it's to the actual landing site is a little to the left of that arrow point right there. Right there. Okay, now notice this crater here. It's a little larger than meteor crater on Earth. And that's to compare it to this crater, which they're going to visit, Camelot crater. Okay, we're going to look at what they have to show us with regard to Camelot crater. That one right there. They landed here. They're going to drive all over the place, as they do now. All right. They're going to go right along the edge of Camelot crater, as if you could drive around the edge of a crater where there would be beaucoup boulders. But anyway, that's what they claim they do. So they should be able to show us in all kinds of detail, without any question whatsoever, without any doubt, a grand crater, right? Well, they don't. Now, Camelot crater is about half the size of Meteor crater, but that's still a very substantial crater. And notice this Shorty crater, which is about 110 meters. I'm gonna point that out in a minute or so. All right, but first Camelot crater. This is what they show us. This is supposed to be a crater half the size of Meteor crater on Earth. Okay, you take half the size of this Meteor crater and it's still a huge, humongous crater. This is not a humongous crater by any stretch. There's the lunar rover to give you the size scale. You can see the rocks on the other side. Again, that's the dead giveaway. In this sharper image, there are the rocks on the other side. If this was really a 600-meter wide crater, you wouldn't be seeing rocks on the other side. And here's a close-up with the rocks clearly visible. Okay, this thing is fake as heck. Now, this is not fake. This is clearly a real hole, a real crater. This is Shorty crater. This is that one that I mentioned I was going to get back to. This is 110 meters wide. Now, they can show this to the bottom, and they do so in all its glory, all right? Why do they do this for this crater and not the others? Because this is a real crater. It's just a small crater, that's all, that they blasted in the desert. They can't show us a huge crater similar to Meteor crater because they had none. They had none. They were on the moon set. They had no such crater. So they had to fake those. But this one they did show us. That's fake. That's Camelot crater. That one looks even smaller than Shorty crater. Because it probably is. And this is going back to North Ray crater from Apollo 16. Okay, this is Apollo 17. We're on Apollo 17 now, but for a second we're going back to Apollo 16. This is North Ray crater. These craters, Camelot crater, North Ray crater, these are phony little craters. They're not what was advertised, large craters on the moon. That's why they don't go to the edge and photograph the inside like they did with Shorty crater. Their craters more or less like this in Arizona or somewhere in the American deserts. All right, now watch this. This is really incredible. Now this is another lunar orbiter photograph pre-Apollo, and we're going to blow it up, so it's going to be a bit fuzzy. Okay, but we're going to compare that to the Apollo 17 landing site, the official photograph of the Apollo 17 landing site, which is that. Now this is fake, and it's fake like with exclamation marks. Because look at this scene here. There's that big crater there, the one okay, we're going to focus on this region right here. Look at that one crater, whereas here you have about a half dozen craters of roughly the same size. These are two completely different landscapes. That is not that. It's that simple. All right, here you have something elongated. Here you have nothing. You have hardly anything. This is Camelot crater right there. here it's not even there. These are two different landscapes. This is different. These are two large craters aligned kind of like this. These are three craters aligned somewhat differently. These, again, are two, clearly, without question, two different scenes. One real, one fake. And here's the dead giveaway. It's frightful, really. Look at this. That peak right there is gone in the fake image. It's so conspicuous, so brazen, that I have a feeling that it was done deliberately by a whistleblower to alert us. Now, notice the shadows are identical. All right, so you can't blame the loss of that peak on different shadows, different sun angles. The sun angles are the same here. Okay, see this shadow here, that shadow there. The shadows are the same, so the sun angle is the same. So this peak should be there, but it's not. Clear-cut fakery. What we're seeing here is very likely an aerial view like this of a crater field on Earth, like this one in Arizona at Cinder Lake. And the indications are the similarity in the sizes of the craters. Okay, all these craters are, the larger ones are about the same size, about 1, 2, 3, 4, 5, 6, 7, 8, 9, more than a half dozen. All right. Like here, you have craters that are cookie cutter sizes. All right. You have set sizes, not random continuous sizes, because the explosive charges were in certain amounts. They weren't random. They weren't, as I said, they weren't continuous. So that's probably what we have here. We have probably an aerial view of an artificial crater field on Earth with the fake mountains added in, and they look phony anyway. Here's the Cinder Lake field, just in case you forgot from early on in this video. That's what we're dealing with. Probably in Apollo 17 as well. And you can see, again, look at the uniformity of the sizes of these craters versus this real image which I showed you earlier. This is one of those mare regions that I showed you where there are all kinds of craters in the mares. Look at the variety, jumble, the chaotic nature of these craters. They're all kinds of sizes. They're all types, shallow, deep, old, new, overlaying each other, overlapping each other, versus this, which is so nice and neat. This is an indication of a crater field, an artificial crater field. Now look at the terrain itself in Apollo 17. It follows the same pattern as all the other missions, which is blank, all right? Where are the boulders? Where are the craters? There are practically none. A featureless terrain with fake mountains. That's South Massive. This is North Massive. Okay. Oh, wow, look at that. Maybe a little boulder, all right? But otherwise, we're dealing with a phony blank landscape with fake mountains. The terrain is so uniform in its featurelessness that they're interchangeable from mission to mission. That's Apollo 17. This is Apollo 15. It could very well be the same moon set, just slightly different backgrounds, fake backgrounds. And here, oh wow, another boulder. Okay, this is, as I said before, or as I mentioned before, they only showed us in total a handful of boulders. This is one of those. It's actually two boulders right next to each other, but we're going to count it as one for convenience. So this is one of just a few boulders that they showed us. Boulders like this would be all over the place. Okay, how is it that you can look almost from miles? I don't know what the distance this is, but you can look far and wide and you don't see any more boulders like this. That's unreal. On the real moon, you would have boulders all over the place. Now, look at this panorama here. And what we're going to see is this is a 360-degree panorama. And what we see is a cubic horizontal all the way across. Okay, this is the panorama in thirds, all the way across. Okay, that panorama in three parts. There's a very conspicuous cubic horizontal all the way across. How can that be? That would only be the case if they were on a plateau. If Apollo 17 landed on a plateau like this, let's say in the middle of this, then you would look all around, and you would have a sharp line, a drop off, like so, like this. Okay, a sharp line and then a distant background. If you were on a plateau, that's what happens when you're on a plateau. Well, the landing site of Apollo 17, which is right here, is not on a plateau. Okay, you can look at it closer, every which way you want to look at it, and it's simply not on a plateau. And the contour map, NASA's contour map of the Apollo 17 landing site confirms this. This is a gradual slope downward, this from upper left to lower right. The Apollo landing site is not on a plateau. If it were, and here it is right there, you would see contour lines around the landing site, like you see contour lines around the middle of this crater, except that you would have a rise instead of a depression. Instead of going deep, you would go up. You would see contour lines around the Apollo landing site, but you don't, because they're not on a plateau of any kind. So this kind of thing, a cubic horizontal all the way around, not just in one direction, is impossible. They were not on the moon in Apollo 17, Apollo 16, Apollo 15, 14, 12, or 11. They were never on the moon, period. Moving on to further fatal problems with the Apollo missions. First of all, heat. The Apollo astronauts were supposed to have worked, walked around, hiked around, literally run around in 250-degree heat. That's how hot the surface of the moon gets because it has no atmosphere. The moon has no atmosphere to mitigate the blazing rays of the sun. We're talking about oven-type heat, hotter than boiling water. And yet, at the end, and by the way, that's my sister's oven there. It's literally oven temperatures. So at the end of the day, these astronauts are supposed to have climbed into this lunar module, which is doing nothing but sitting there soaking up the sun. This is one of the astronauts right there. All right, at the end of their workday, and I say workday because the actual day on the moon lasts 2 weeks. So there's no respite from darkness, from night, for 2 weeks. So literally, the lunar module is just sitting there soaking up the sun. It would have to be an oven when they go in there to try to sleep. The lunar rover, what kind of magical car is this that can stand 250-degree heat? And how can the astronaut just sit on this thing? All of these materials would be getting up to 250 degrees. Imagine a car in our summers on a hot summer day. remember how hot that is. And this is over twice that heat, because I mean, on the Earth we're talking, you know, something like 100 degrees. This is twice that heat. The lunar rover, this is the operations handbook, states explicitly that you can't operate this thing over, well, here operating temperature at maximum 125 degrees. The survival, whatever that means, like this, you know, the car would croak. 140 degrees. This, by the way, is for the battery. But you can imagine that the entire car is not designed to withstand 250 degree heat, because what vehicle is. These are the Hasselblad cameras that the astronauts used. They're very fine cameras, but they're essentially just slightly modified versions of commercial products. Earthly cameras, not designed to withstand huge amounts of heat. The modifications were minor, like larger controls, so that the astronauts could flip these things with their gloved hands. These cameras were not totally redesigned. They were essentially like that. And like any other ordinary camera, they had internal gears and delicate mechanisms, some plastic parts. Okay, all of these things would be adversely affected by 250 degree heat. You know, these things are precision little mechanisms, and the plastic would start to melt. The lenses, like any other lenses, are closely fitting in these metal and plastic rings. All right, all of these things are not designed to withstand extreme heat. This is a regular camera, a Canon camera, and the specifications sheet says that the maximum operating temperature is 113 degrees. Here's a Nikon manual on temperatures, and it says Nikon cameras are designed to work under specific operating temperatures. These temperatures are between 0 and plus 40 degrees centigrade, which is 104 degrees Fahrenheit. This is the kind of temperature that cameras are designed to work in, maximum, a little over 100 degrees. Same thing with TV cameras. These are the cameras that TV cameras that the Apollo astronauts allegedly used. And here's a couple of them, one there and one there. And here's the still camera, the Hasselblad, by the way. All of these are sitting there soaking up heat up to 250 degrees. Remember that. And here's the TV camera operations manual. It says explicitly, the camera case should never be allowed to reach a temperature colder than that or hotter than 120 degrees Fahrenheit. Now, the astronauts themselves are supposed to have been in air-conditioned suits. These suits are supposed to have been air-conditioned with tubes flowing with water flowing through them. Okay, that was supposed to be their air conditioning. However, there's no evidence that this actually worked, because this is a closed system. You have to expel that heat, just like in a room with an air conditioner. The heat has to be taken out of the room. A hot car, you have to expel the heat through some medium. Okay, air in normal air conditioning, or liquid. But this is a closed system. You can't have air conditioning without an escape of the heat, and there's no evidence that anything ever escaped. The liquid, the hot that was heated by the astronaut's body. All right, there was never any evidence that anything was ejected out of this suit. Here's what Ralph Renee says. If they had really had suit air conditioners that worked, every time the suit was vented into the high vacuum of space, the rocket effect should have been spectacular. A rapidly expanding fog of ice crystals, that's what NASA says, it's more likely to have been water droplets or steam, would have reflected the brilliant, unfiltered sunlight, spraying millions of tiny diamond-like crystals about and producing a brilliant, dazzling, and unforgettable display. We can be sure our astronauts never released water in this manner, since not one of the thousands of pictures taken on the moon has ever shown such a display. This is sort of what we would expect to see. In this case, somebody tosses hot water into cold air, but whether these would be ice crystals or water droplets, steam, whatever, you would have seen something like that shooting out of the astronaut suits on the moon. But we never saw anything of the sort. Overall, NASA never explains in a serious, believable manner how they dealt with 250-degree heat. Look at this lunar module. It is laughable. It is literally laughable. This is supposed to be a spaceship. What is with all this junk? Okay, and the haphazard manner in which it's distributed. Okay, they say, well, we have to have reflection to reflective material to reflect heat. Well, why is this dark? Okay, and why is this light and this is dark? Well, everything is haphazard here, arbitrary, totally. It looks like a bad high school project. Look at the fit and finish. There is no fit and finish on this thing. Everything's warped. It looks like, you know, a poorly constructed thing, to say the least. And critics have had great fun with this. NASA claims they went to the moon in this pile of shit. All right. And if you zoom in, you can see foil, tape, and curtain rods. Literally, these things are for all the world like the curtain rods our family would get in the 70s from the department store. All right, that looks like a cheap curtain rod. And what is this foil or paper of some sort? And that's tape. That's Scotch tape. What nonsense is this? This is supposed to be a spaceship. Look at the lack of neatness. You know, no, as I said, no fit and finish. Warped panels, paper. This is supposed to be a precision rocket or a set of rockets to, you know, guide the spaceship through space with extreme precision. This guy says it all. What the bleep are these? Blow dryers? So, you know, parts you need to build your own spacecraft. Lots of big sheets of cardboard, a big roll of paper, a few old curtain rods, some floodlight holders, an old TV antenna, a roll of gold foil, some small plastic and rods, a few used egg cartons, and lots of Scotch tape to hold it all together in the hostile environment of the moon. Now look at this here. This is the ascent stage. This is the descent stage. The lunar module is in 2 stages. This is the rocket that brings it down to the surface, and then there's a rocket in here which is used to blast off from the surface of the moon. And only the ascent stage, the top half here, the cabin with the astronauts in it, leaves the moon, and it leaves this behind. So this is that ascent stage. This is Apollo 16, supposedly orbiting the moon, or going back up to meet the service and command module. And this photograph is taken from the command module by the astronaut that's left up there orbiting, while the other 2 are on the surface. What on earth is this? Look at this. I mean, this is ridiculous. That's supposed to be a spaceship. That's supposed to be a precision machine. It's a bad joke. Okay, so you say, well, it's suffered some kind of damage. Yeah, but still, it looks ridiculous. I mean, you know, my vocabulary is limited when it comes to these descriptive terms. It's farcical. How's that word? Farcical. The lunar module has been described as a piece of junk, looking more like a homeless person's shelter or a cardboard shack in a Brazilian favela than a spaceship. Gerard Wisniewski says, it looks more like a slum dwelling after a hurricane than a vehicle suitable for traveling in space. That pretty much says it all. Compare that lunar module, that joke of a spaceship, to this actual spaceship, which is the DCX. This was developed in the late 1990s. It was designed as a reusable spaceship to go up into Earth orbit and come back. And look how nice and neat it is, and aerodynamic, and well constructed, apparently. Compare that to this thing. Now, of course, NASA will say, well, you don't need aerodynamics in the vacuum of space, and in the vacuum, which is the surface of the moon, which is true, but still, we're not just talking about aerodynamics. We're talking about something reasonably professional looking. Further evidence that this whole thing was a joke is that they never actually landed this machine on the Earth, much less the moon, in training. Okay, the first use of that lunar module was the one, Apollo 11 landing, the actual thing. There was never any practice run. Whoever heard of such a complex, such a important piece of machinery not practiced on beforehand? This is what they trained on. The Lunar Landing Training Vehicle, or another term was the Lunar Landing Research Vehicle, which is nothing like the lunar module. So in other words, they never did train on the lunar module. This thing here operates on jets, not rockets. It's nothing like the lunar module. Here's supposedly an astronaut or somebody training with this thing. And as a matter of fact, that machine crashed a number of times, including once with Neil Armstrong flying. And he barely escaped with his life. Here he is parachuting from this thing after it crashed. Or just before it crashed, I should say. So here's what Dennis Cimino says about Grumman's lunar module plans. Grumman was the manufacturer. I looked at these drawings extensively. The designs are completely and wholly inadequate. Anybody with any physics and design background would take one look at it and dismiss it offhand as being foolish and goofy. Bill Woods, another engineer, says about the lunar module proposal from Grumman, a 110-page document for a $6.9 billion program is an outrageously small document. There's no way that a reviewer could determine whether or not the contractor is going to accomplish anything worthwhile based on 110 pages of documentation for that size program. Programs of similar size and cost are tens of thousands of pages long. He continues, you wouldn't need a very long proposal if you weren't really going to build a lunar module that really had to work. If you were going to be building lunar modules that ended up in museums or on displays, then you could probably do that for a few $1 million, and that might only require a 110-page proposal. So multi-billion-dollar projects like this aircraft carrier or this nuclear submarine, those require huge amounts of documentation. Like Bill Wood said, what is it, thousands of pages, all right? But this lunar module never did go to the moon. It was always just a model, like a toy, and it ended up in museums, all right, the various specimens. So yeah, so they got away with a very small 110-page proposal because that's all it was for. It was always just for show. It was never a real flying machine. More evidence that it wasn't for real. This is a real rocket, a 7,500-pound thruster, and of course it shoots out a flame, okay, or a plume as another term for that. Who ever heard of a rocket without a flame? Even the space shuttle in the vacuum of space produces a flame. So the fact that the lunar module was in a vacuum is no reason at all that it would have no flame, no plume. Now, on this website, which tries to explain away all the anomalies of Apollo, this is Clavius, this website right here, Clavius. They try to say that flames don't always have to, excuse me, that rockets don't always have to produce flames. But the example that they use, where they say that the flame is almost invisible, is nowhere near almost invisible. You can clearly see this plume, and you would certainly see it in the black vacuum of space. And in fact, all the depictions of the lunar module before its actual use showed a prominent rocket flame. There and there and there. All right. And as a matter of fact, the team that constructed one of those lunar modules, this one right here, and by the way, this isn't Apollo 10, this is just the number of the particular lunar module that these guys made. The builders of each lunar module were given the privilege of designing the insignia or patch for the lunar module, and these guys made one with the flame, the rocket flame. In Wernher von Braun's book, he shows the rockets landing on the moon with a large plume and also taking off with flames trailing the rockets, right? Common sense, or not just common sense, rocket science says that rockets have flames, but not Apollo, not the lunar module. Here it is, the ascent stage blasting off from the moon, and not the slightest hint of a rocket. There's a still photo. No rocket whatsoever. And not only did the lunar module produce no flame, it produced no sound, which is even more unbelievable, because there definitely, without question, would have been a whole lot of noise involved with these rockets. So this, by the way, is when the thing takes off. There would have been explosions, which I'll explain in a second, but there is no such thing recorded in the audio recordings. And in the famous descent of the lunar Apollo 11 lunar module down to the surface, there was no sound at all. You can listen to this and you will hear no rocket noise, just the astronauts' voices and Houston. So this is what Gerard Wisniewski says. And here he's speaking specifically about when the ascent stage of the lunar module takes off. He's talking about this point right here, at this point right here. Explosions would cause the module to shake when the ascent stage breaks away from the landing stage with the help of explosive charges. When the abort stage button in the cockpit is pressed, the bolts that have been holding the landing and ascent stages together are released. At the same moment, knives driven by explosive charges cut through the various cables and leads. With all this going on, the lunar module should have been trembling violently. Wernher von Braun says, at x minus 4 seconds, a thunderous rumble will sound in the passenger spheres. The rocket motors have started. In many of the Apollo recordings of both the descent to and ascent from the moon, I have not listened to all of them, this is me speaking here, there is almost complete silence except for the astronauts and Houston's voices. There is no significant background noise from the rocket engines or any other source. The Apollo 11 descent is infamously quiet. The Apollo 16 ascent is one partial exception. There was a slight explosion. Of course, in a real moon landing program, all of the descents and takeoffs would be very noisy events. Regardless of the vacuum in the lunar environment, and therefore no possibility of sound outside of the spacecraft, the inside of the lunar module is filled with air and therefore sound. Furthermore, the structure of the spacecraft itself would transmit the vibration and sound of the engines. In the NASA report on the Apollo 13 explosion in the supply model, and that was the famous explosion that derailed the Apollo 13 mission, it says all three astronauts heard and felt a pretty large bang. And one of the astronauts, Lovell, says, we all heard the explosion together. So there definitely would have been sound associated with the rockets of the lunar module. Here's the ascent rocket. It's inside the cabin. as shown here. Here's the astronaut literally a foot or two away from the engine. Although the astronauts in the lunar module were only about 40 centimeters away from the running rocket engines, there is no engine noise to be heard in the background to the radio communications. Okay, so that was the ascent rocket. Here's the descent rocket, and it's also within the structure of the lunar module. If not in the sharing the air of the lunar module, it certainly is connected structurally to the lunar module in general, and therefore it would transmit vibrations and sound. Now, many researchers say that this rocket should have caused a crater on the moon, and there's never any such crater. The NASA rebutters say that the rocket wouldn't have had to be that strong because of the moon's 1/6 Earth gravity, and there's some plausibility there. So let's say for the sake of argument that a crater is not a necessary result of that rocket. Okay, well, at least, and it's a very powerful rocket, 10,000-pound thruster, at least you would expect that the sand, the dust and sand and loose dirt would be blown away, all right? That there would be some effect of that rocket. But in the photographs of the lunar modules right underneath them, after landing, in all of them, there is not the slightest indication of that rocket actually having been used, having been blasting the surface. All of the dirt is undisturbed. The dirt is undisturbed. And you can see that nothing is blown away because the footprints of the astronauts, okay, are clearly visible there. And so it wasn't blown away. The dirt was not even blown away. So not only did the rocket produce no crater, which we'll grant as a possibility, it didn't even disturb the surface at all and didn't blow away the dirt, which is unbelievable. Now compare that lunar module to this, the DCX, which produced a flame. It made a lot of noise when you watch the videos of this thing taking off. And it also produced craters, small craters in the desert, in the surface of the desert where it landed. So much so that the project designers were afraid that the thing would tip over because it would land unevenly in the crater that it made. So the DCX produces flame, noise, a small crater. Apollo lunar module, nothing. Another problem with this alleged spaceship, it is extremely ungainly. It's top heavy, and it only has one rocket. So in this illustration, this here would represent the one rocket lunar module, and this would be a much more efficient design, more effective. This easy lander would be much easier to control. First, it isn't tall and skinny like the Falcon 9. The center of mass is much closer to the main thrusters so that they wouldn't exert as much torque to change the rotational motion. On top of that, there are multiple thrusters so that you could vary the thrust to create zero torque if you wanted. So this is the design of the DCX, broadly speaking. It has 4 rockets on its broad base, at each corner of its broad base. That gives it a whole lot more stability and maneuverability. And as a matter of fact, unlike the lunar module, this was actually tested successfully. Here, I guess here it is. Yeah, it takes off, all right, and lands successfully. They did a number of tests of this thing, and it worked. Now, we can ask, why on earth are they testing this thing? Why are they having to design a new rocket and a whole new rocket design if Apollo had worked so well? Why wouldn't they just continue using Apollo? The high center of gravity lunar module has been deemed inherently unstable in its vertical axis by engineers. Such a machine would have been nearly impossible to balance with the heavy lunar rover stored off-center. Any slight inertia going sideways would be difficult for the reaction jets to correct. The lunar module could be stabilized with modern computers, but these were not available in the 1960s. Ralph Renee says, how do you land an unwieldy single-jet vertical landing machine that's unbalanced? So, to sum up, this thing here was not a real spaceship. It didn't ever land on the moon. It was a large stage prop. Now let's look at this trip to the moon as a whole. It was extremely complicated. There were 100, in this diagram here, there are 134 separate steps. Now, Wernher von Braun had proposed building a space station before going directly to the moon, and that would give the astronauts, NASA, a lot of experience, you know, playing around in space, basically. But no, NASA decided to go directly all the way to the moon. Nothing like this had been done before. Nothing remotely like this had been done before. Just blasting off and getting into orbit and coming back down is a much simpler procedure. There's no way I'm going to go through all these steps, especially in this complicated diagram. So we'll look at this simpler diagram. And even here, there are 20 separate steps. So to get a feel for, you know, just how complex this whole operation was, we're going to go through these steps. So you have blast off, and then the first stage separates, then the second stage is ejected, and so you're left with a third stage. And then this stage fires to get the spaceship out of Earth orbit and on its way to the moon. And then after that, there's a complex little operation, a little maneuver, where the service and command module, that's the command module right there, that's the service module. For now, they're like one spaceship. The service and command module comes out of that last stage, does a somersault, and then connects with the lunar module, which is inside here, and then pulls out with it, so that you have the combined service command module and lunar module together. And then after that, okay, that's this operation here. And then after that, they jettison the last stage, rocket stage. Okay, so here they are. They do a mid-course correction, and then they get closer to the moon and they do a burn for lunar orbit insertion. And then once they're either near the moon or in orbit, they separate. The lunar module separates from the service and command module, and then the lunar module descends, and then it lands. And then after the astronauts have done all their running around and exploring and all, then you have liftoff of the ascent stage from the moon, leaving the descent stage behind. And then you have a rendezvous where the lunar module redocks with the command and service module. And keep in mind that none of this has been done before Apollo, the first Apollo that went to the moon, which I believe was Apollo 8. None of this had been done before in full. Okay. All right, so the lunar module is jettisoned because it's no longer needed. And then they do a burn for a mid-course correction. And then once they get close to the Earth, the service and command module separate, and the service module, they get rid of that. So then you have the command module, and then it goes into the atmosphere. And this is a very, very tricky procedure here, because it has to come in at just the right angle so that it doesn't either destroy itself with too much friction, too much heat, and too many G's, too much gravity, or it could skip off if it comes too shallow, it can skip off the atmosphere and end up in space, outer space. So anyway, so they do that, and then finally splashdown. So in this simplified model, you still have 20 separate delicate procedures that have to be done precisely. Bill Kaysing, citing a 1959 Rocketdyne study, noted that the statistical probability of humans getting to the moon and back is 0.0014. That's just a little over 1 in 1,000. He says there were 85 separate maneuvers involved in each lunar landing. The statistical probability of complete success 6 times in a row without a single failure is practically 0. And here he's talking about the 6 times where they landed on the moon. Overall, they went to the moon 9 times and came back successfully. The only glitch was Apollo 13 with that explosion, which ended up being a success story anyway. And really, they undoubtedly did it for drama more than anything else. The whole thing was a show, and that was part of the show, and that just added a little bit of human drama. And it was just a success story after all, how they persevered and all that. In real life, for instance, with the shuttle program, you have accidents. They're almost inevitable. You had 2 huge accidents with the shuttle, the Challenger and Columbia, and NASA lost 14 astronauts. But here's Apollo with 1960s technology going all the way to the moon and back 9 times with not a single loss of life or injury. It was downright magical. But of course it didn't happen, and NASA admits it. In this fairly recent video, Orion Trial by Fire, this NASA engineer, Kelly Smith, explains in great detail how this second generation spaceship, the Orion capsule, is going to go all the way to the moon or other bodies, allegedly, like Mars or asteroids. Okay, this is an animation. This ship never actually took off, but that's what it would have looked like. And here it goes to, let's say, the moon. Okay, because they intended to go back to the moon according to this project here. All right, and he explains all of this and the spacecraft coming back, just like it did with Apollo, parachuting back. Okay, the whole operation is described as if it had never been done before, as if it was totally novel. Smith describes every stage of the Orion mission, a successor and in many ways a close copy of Apollo, as if it's never been done before. Everything is described exactly as if it were completely novel, as I just said, as if we had not yet gone into space beyond Earth orbit. And there's no mention whatsoever of Apollo, just as if it had never existed. And during this video, Smith describes the dangerous high radiation Van Allen belt zones that the astronauts have to go through, that the spaceship has to go through. And the video shows this with these garish colors to make it seem, all the more scary, which it would be in real life. And he says, as we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Sensors aboard this first unmanned craft will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. What more does one need to hear? They have not solved these challenges. Okay? And they have not sent people through this region of space. Notice that the first craft is unmanned because they need to study the radiation levels. What is all this about? All this is saying, in so many words, that Apollo didn't happen. And this is reinforced by the words of this guy, Terry Virts, a NASA astronaut, ISS International Space Station commander, who says this. The plan that NASA has is to build a rocket that will be able to launch the Orion capsule to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the farthest that we can go. And this new system is going to allow us to go beyond and hopefully take humans to the moon, Mars, asteroids, and we're building these building block components in order to allow us to do that eventually. Listen to what this guy says. He's speaking English. We understand English. He's saying that they didn't go anywhere. Right now, we can only fly in Earth orbit. That's the farthest that we can go. How much more explicit can anybody say this? Hopefully, we'll take humans to the moon. And we're going to do this eventually. They have not gone before. That's what he's saying here. And this astronaut, I don't know her name. The video never told us her name. She says, we're really pushing the boundaries in terms of where we're going forward with exploration. This is really the beginning, I think, of human beings leaving low Earth orbit. Are we supposed to believe she never heard of Apollo? No, she knows all about Apollo. She knows it was fiction. She's speaking the truth here. Human beings have not left low Earth orbit. And this is evidenced I've shown you many reasons, but this one here is quite compelling. Here is Apollo 13, 200 miles toward the moon. In other words, almost there. 200,000 miles is what I should have said if I didn't. And what do you see? Blue sky in the windows of the Apollo spacecraft, hundreds of thousands of miles away from Earth. They were not near the moon. They were in low Earth orbit. That's all this space program did. They got people up there in weightlessness, acting like they were traveling to the moon. They weren't going anywhere. This is as far as human beings have gotten with their own spacecraft. Now, frankly, UFOs, alien spacecraft may have taken humans farther. Who knows where? But with our own technology, with our own spacecraft, this is the farthest that we've gone. This is, by the way, the International Space Station. Just a couple hundred miles, 250 miles beyond the surface of the Earth. This is how far the moon is. About 1,000 times further than this distance here. It's an order of magnitude, if not several orders of magnitude, more of a voyage. All right, it's a whole different story, and we've never done that. We're talking 30 Earth diameters distance. That is a formidable venture that we haven't even tried, not even started to try, much less accomplished. This is the press conference held by the 3 Apollo astronauts, Apollo 11 astronauts, once they had returned to Earth from their tremendous journey, right? Look at their demeanor. And when you watch this, the whole press conference, not just photographs, the photographs say a whole lot, but when you watch it on film, it's unbelievable. I mean, it's incredible how downcast they are. They are anything but joyful, anything but joyful. At this stage, Buzz Aldrin is droning on about some technicalities, and look at Neil Armstrong there, and Michael Collins. They're frozen in thought for quite a few moments, and this is more or less the tenor of the whole thing. It's just amazing. And these are my notes on the whole thing. The mood is downright funereal, the farthest thing from triumphal, joyful, or giddy you can imagine. The men are extremely stiff, clearly very uncomfortable. There's no fluidity to their speech. It's mechanical and consists entirely of sequential monologues, as if they're delivering scripted parts in a play. There's not the slightest convivial banter between them. There's little authentic detail about the voyage in their talk, except for some technical mumbo-jumbo, nor any spontaneous anecdotes recounting unique experiences, as one would expect in an account of a tremendously exciting, wondrous, and mind-bending experience. Practically nothing in what they say is fabulous or enigmatic. It's all humdrum, unexceptional, perfunctory. Very weird and phony overall. And this is what Dennis Semino says. The body language, the facial expressions. These are men that are under duress. These are men that are not happy. These are men that are very, very displeased with the fact that they're on the spot being asked difficult questions. And they're not just being asked difficult questions. They are living a lie, and they know it full well. And not only a lie, but a murderous lie. They saw their companions murdered for this lie, including Gus Grissom. Gus Grissom was very critical of the program. He wasn't going to go along with the baloney. And at one point, he even hung a lemon on the capsule, on the Apollo space capsule, because that's what he thought it was, and he made it clear. So Grissom was an aircraft engineer. He was constantly inspecting the Apollo capsule and finding many things faulty with it. I have been howling in the wilderness for years, he said. He called the capsule a bucket of bolts and threatened to go public with his complaints after the lemon incident. Gerard Wisniewski says, Grissom simply refused to participate in the whole hocus-pocus surrounding the myth of the legendary Apollo spacecraft. Grissom received death threats, and on some occasions he was provided with guards and housed in special safe quarters. He told his wife Betty, if there ever is a serious accident in the space program, it's likely to be me. And how prophetic he was. Because there was an accident, a deadly accident, on the launch pad with the Apollo space capsule. Grissom and his companions, his colleagues, White and Chaffee, were stuffed into this pressure cooker. And I mean that literally because they filled it with pure oxygen under high pressure. And it burned and incinerated them. It simply charred them to death. The capsule had 1, an extremely flammable atmosphere of pure oxygen under abnormally high pressure. 2, an inward opening hatch, impossible to open quickly under pressure, that had been changed that very morning from the normal outward opening hatch and which was bolted from the outside and lacked explosive bolts. 3, a tangle of electrical wires, switches, and circuits prone to sparking, plus lots of flammable materials. Ralph Renee says, any competent engineer should have known the dangers of oxygen at 16.7 or 20.2 psi, and normal atmospheric pressure is 14.7 psi. And by the way, Ralph Renee is uncertain about this because NASA itself doesn't say exactly, but we know it was abnormally high. Keenan and Harvey, 2 observers, said, most U.S. scientists could not believe their ears when they learned the facts. Oxygen at such pressure comes in the category of an oxygen bomb. This instrument here, it's an actual instrument. A calorimeter bomb is an instrument that utilizes a combustible material, pressurized oxygen, and a spark. That's exactly what the capsule was. That's what they made it. A New York Times editorial said, even a high school chemistry student knows better than to play with 100% oxygen. Bill Kaysing and Ralph Renee call it simply murder. The FBI and NASA immediately ransacked Grissom's home and took all his paperwork, including his personal papers and his diary. Why would they have needed to do that if there was nothing fishy going on? And they weren't finished with the killing. This young man, Thomas Barron, was a safety inspector employed by North American Aviation, Apollo's prime contractor. Before the Apollo 1 fire, Barron had written a 55-page report on sloppiness at the pad, demanding that North American Aviation implement checks at the highest level. Someone had to make known to the public and the government what infractions are taking place, he said. After the fire, Barron testified before a congressional committee on the disarray of the Apollo program, asserting that the U.S. would never make it to the moon. And then he submitted an additional 500-page report. Julian Scheer, a former NASA spokesperson, recalled that, quote, there was a real fear that the program could be stopped dead in its tracks. 1 week after testifying, Barron, along with his wife and daughter, were struck and killed by a train as his car was inexplicably stuck on a railroad track crossing a Florida road. His report on the inadequacies of the program disappeared. How coincidental. 1 week after testifying, Barron is killed. And more coincidence. The report disappeared. Nothing to see here, all just chance. And that headline says it all. Crash kills Apollo critic Barron. They killed this guy. They killed this man, just like they killed Grissom and his companions. They killed his family. Finally, and almost most bizarrely, the astronauts claimed that they went all the way to the moon and back and essentially didn't see stars. What they say, that the record on this topic is confused, it's contradictory, it's inconsistent, okay? But broadly speaking, they claim that they didn't see any stars on a space voyage. Now, many Apollo critics look at photographs like this from the surface of the moon, and they see a completely black sky with no stars, and they say, well, there should have been stars here. Okay, that's actually incorrect, because in these photographs, this is in daytime. They're on the surface of the moon, but they're under the sun. They're in daylight. They're using daytime exposures on their cameras, and that means very little light into the cameras. And under those circumstances, there is not enough light to make out the relatively dim stars. That's true. Okay, but that doesn't explain why they couldn't have seen stars with their naked eye. Forget the camera for now. Okay, all they had to do to see the stars was raise their visor, which acted as large sunglasses, keeping light out, like this guy did. Here we are this guy's supposed to be on the moon, and he raised his visor, and they did that a number of times. Okay, and then look away from the sun, preferably get in the shade of the lunar module or a boulder, and you would see the stars. And Wernher von Braun, again, much more realistic than Apollo, recognized this, and that's why in his book he has illustrations with the stars. And what he does here is he has the sun blocked by the top of this spaceship here, and the Earth is a new Earth, kind of like a new moon, where you only see the shadow. So there's no bright Earth in the sky either. Under those circumstances, he not only shows stars, he shows the Milky Way. All right, that's what you would see on the moon with your naked eye. In fact, on Earth, with our light-scattering atmosphere, which blocks, our view of the stars in general, you can see Venus in the daylight, if you know exactly where to look. So imagine if we had no atmosphere at all, we would certainly see the brightest star, at least the brightest stars and planets. Now, the astronauts were asked this question specifically: did you see the stars? Okay, they look all confused and hem and haw, and this is what they said. Question: when you looked up at the sky, could you actually see the stars? Armstrong said, "We were never able to see stars from the lunar surface." And then Collins said, "I don't remember seeing any." And Dennis Semino says, "No matter what NASA wants to say about the contrast levels and the optics, you'd see stars." Now let's look at, let's examine this statement by Collins in particular, okay? Collins, this guy right here, he never was on the surface of the moon. Only these two were on the surface of the moon. He was in the command module orbiting the moon all the time. And he was going around and around the moon many times because the orbit was something like 90 minutes or something. And they were there for well over 24 hours, I believe. Anyway, so he went around and around the moon, and on each of those orbits, he was on the dark side of the moon. That's why they call it the dark side of the moon, the side of the moon away from the Earth and away from the sun, all right? And on the dark side of the moon, he would have seen nothing but stars in the sky, all right? When he looked at the moon, it would have been black. But when he looks away from the moon, the sky would have been fantastically full of stars. And it would have been just memorable, to say the least. He would not have forgotten that experience, to say the least. And here he is saying, "I don't remember seeing any." It's absurd. It's a lie. It's a blatant lie. Now consider the Hubble Space Telescope. Okay, here it is photographing the sky, stars, and celestial objects in daylight on the day side of the Earth. And why can it do that? How can it do that? It can do that because it's above the atmosphere. All right. So it's seeing a black sky just like the astronauts on the moon. And so what they do with the space telescope is that they use long exposure photography. As a matter of fact, the Hubble Space Telescope takes exposures not just in minutes, but hours and days at a time. And it goes around and around the Earth, like 90-minute, that's about the standard, something like that, on that order. 90-minute orbits, and half the time it's in the day, in the dark, on the dark side of the Earth, the night side, and half the time it's on the day side. But it doesn't shut down when it gets on the day side. It keeps on photographing. All it has to do is avoid pointing toward the sun. In fact, photography of the stars is not a problem during the day where there is no atmosphere to scatter the unidirectional light rays from the sun, as long as one uses long exposure, in other words, night settings. That's all you have to do. And you can do that, the astronauts would have been able to do that on the moon as well, okay, if they had taken one of their cameras and put it on a tripod, if they had taken a tripod, which they would have if they were serious, or just place it on a rock or something, and use long exposure settings instead of the day settings that we saw earlier, okay, where they took normal photographs. They could have taken long exposure photographs. And this is what they would have been able to photograph: a pristine, tremendous view of the night sky from the moon without any atmosphere to interfere with the view. They would have taken fantastic photographs. But they couldn't do that because they couldn't fake the sky. They could fake the lunar terrain because we don't know what the lunar terrain looks like. We haven't walked on the moon. But we do know what the night sky looks like. Amateur astronomers as well as professional astronomers, we know quite well what the sky looks like. For instance, in this photograph here, I recognized the constellations. This is Ophiuchus here. This is Scorpius here. And this is Libra here. Okay, and the individual stars, some of them I know, like Antares. These two very bright things are planets. This is probably Jupiter. I'm not sure which planets these are, but the point here is that we can determine where all the stars are and all the planets are or should be, because astronomers can do that. And so you wouldn't be able to fake a night sky, a photograph of the night sky. So what did they do? NASA, since they weren't on the moon, okay, they wouldn't have been able to get it right. They decided no stars. That was the party line. NASA took 3 lunar rovers all the way to the moon, but not one small photographic telescope with which to record the sky from the moon. Astronomers dream about an atmosphere-free moon observatory. The Apollo astronauts, on the other hand, display complete indifference to the night sky. They do nothing but collect rocks. Astronomical observation would have been a high priority in a real scientific mission. To conclude, I have shown you an abundance of evidence, a veritable torrent of evidence that demonstrates conclusively that Apollo was a lie, that we have not gone to the moon. We did not go to the moon with Apollo. It was all just a show. The U.S. government's moon landing program has been called, quote, the crowning achievement of humankind, the greatest boast of the species, the event in human history most associated with pride in our own accomplishments, unquote. That was from one of the videos. It did not happen, period. The plain fact, proven copiously and beyond doubt in this study, is that it was an extremely elaborate hoax, as I believe Dennis Semino said early on. A stupendous lie, a lie on a scale unprecedented in the history of the world. The moon is undoubtedly a fantastic place, probably a very beautiful place in its own way. But it is not a friendly place to visit. It's more like this asteroid Vesta, a dead world fully exposed to radiation and micrometeorites, and not a friendly place to visit. Not like this depiction, which for all the world looks like people driving around and hiking around in a national park here on Earth. That is phony baloney. NASA's moon is bland, featureless, washed out, insipid, innocuous, sterilized, sanitized, neutered, Disneyfied. In short, a fictitious cartoon version of the real moon. Nothing but a platform for American propaganda. This is what they show us. A smiley face malarkey moon. As I said, a vehicle for American propaganda. Nothing more, nothing less. This is very interesting here. This is a book by Zbigniew Brzezinski, a neoliberal, a arch neoliberal. This is the German edition of his book, and the book in English is The Grand Chessboard, American Primacy and Its Geostrategic Imperatives. All right? And the German translation that they used is Die einzige Weltmacht. Excuse my German. And that means the only world power. That's what Apollo was all about. That's why on this, on the cover of this book about world power, they use not a photograph of B-52 bombers or B-1 bombers or American skyscrapers or anything of the sort. They used an iconic photograph from Apollo, a staged photograph actually from Apollo, to show the conquest of the moon. So this was a huge propaganda coup. And nothing says it better than this title, than this book cover, proclaiming the only world power. This was staged on an Earth moon set. Gerard Wisniewski summarizes, at the conclusion of a decade of murders, unrest, and coups d'etat, a period of war crimes and villainy, the moon landings of the 12 American heroes appeared like a form of catharsis, purifying the whole country and its international image of all that inexpressible filth. The landings on the moon were certainly one giant leap for the United States of America, away from the menacing image of a rogue state and towards that of a homeland for the true, the beautiful, and the good. To this day, the USA draws strength from the boundless admiration generated by those lunar landings. This conquest of the moon, that ancient myth of humanity, elevated America to the status of a quasi-divine nation. The moon landings fit in with the country's overall psychological strategy of self-aggrandizement coupled with subjugating, undermining, and demoralizing others. And he continues very incisively, the might of the United States of America derives not from its military machine, its atom bombs, or its financial and commercial strength, but from its lies. With this achievement, in other words the moon landing, the USA showed everyone, once and for all, who had the final say the world over. It was a lie intended to establish ideological and political dominion over the globe. And the biggest lie of all is that this country, our political system, our government, our form of government is a democracy. That is pure nonsense. The U.S. government is in fact an outright criminal regime, as mind-boggling deceptions like Apollo prove unequivocally. In reality, the quote-unquote representative institutions of our government represent the elite, not ordinary people, and the members of this ruling class are clinical sociopaths, indeed homicidal maniacs. Although presumably human, in practice they are effectively demonic beings, a political order in which such creatures wield godlike power over the citizenry is anything but a democracy. So on the surface, we seem to have lovely institutions. Okay, isn't this nice and pretty? A nice Congress with a nice House of Representatives and a nice Senate, nice president, you know, very respectable looking ladies and gentlemen as our leaders. Okay, this is all a facade. These people represent these people, or people like this. If, in case you don't recognize these guys, this is the Rockefeller brothers. That's David and that's Nelson. I know those two for sure. Bill Gates, Warren Buffett, the Koch brothers. These are the kinds of people that really rule behind the scenes. These are the people that the U.S. government answers to. And not just those high-profile people, but people like this. These are the bankers, the CEOs of the banks at the time of the, I think, 2008 recession, or 2012, whatever, whenever it was. And they were going to see Obama, okay, and they were going to plead his help. And Obama, they had nothing to worry about. Obama said, I'm on your side, guys. And of course he was, because he's their servant. All American presidents are the servants of this class of people. And those people, although they look, you know, they look like human beings, they probably are. But for all practical purposes, they are monsters. And they lead our country in monstrous ways, down monstrous paths. This state of affairs is not happenstance, and it is not a temporary condition. It is the direct and inevitable consequence of an oligarchical political system that ipso facto must be replaced in toto and immediately. When you really get down to the specifics, the real deal, okay, the bottom line, what we're talking about is the United States Constitution. This business about, quote unquote, we the people ruling through this Constitution, this system of government, that is a pure falsehood. It's nonsense. We do not live in a democracy of any kind. And that's why this system has to be changed, and changed decisively. And that's what we're about, the Revolutionary Alliance for Truth and Democracy. And do visit our website. Thanks for listening. Thanks for watching and having patience with this long and trying video. Thank you.